Okay, I guess we can start now. Is my screen visible?
Yes, ma'am.
Yeah, ma'am.
Good evening, ma'am.
Good evening. Just a second. Okay, so today was basically about week 7 and week 8, but I saw the contents and it's mostly about dictionaries, right? There is no new concept or anything that we can do from there. Everything is covered. So I thought it was better that we discuss the mock solution instead, because there are a lot of good questions from that dictionary part. So we'll discuss all the questions from the mock.
Yeah, ma'am. Yeah, ma'am. That is
Yes, ma'am.
Ma'am, before starting with the mock, can you please give some idea about the dictionaries?
Yeah, sure. I'll give you a brief about what is dictionary.
Okay, ma'am. Thank you.
Okay, is the font okay? Can everyone read?
Yes, ma'am.
Yes, ma'am.
yes.
Alright. Okay, so what is a dictionary? It is basically a storage unit, we can call it, right? Like, first thing is, what is the difference between list and dictionary? Anyone wants to try? What is the difference
List
main
has a
difference between
random
list?
access, but dictionary has random access.
Correct. So in list, we have to traverse the entire list to access any element, right? So it does not have random access. So no random access. But in case of dictionary, we can have random access using the key value pairs, right? Using the keys, we can access any element. Okay. So in dictionary, are the keys can be duplicate or not?
No, ma'am. They should be unique. Key should be unique.
So this is one key value pair. This is how every entry in a dictionary looks like. So
Yes, ma'am.
keys should always be unique, but values can be duplicates, right?
Yes, ma'am.
Can be more.
Sorry?
Values can be more.
Yeah, values can be anything. Yeah.
Ma'am,
Okay.
is key and index is same?
Key and index.
Yes, ma'am.
In dictionary, we do not use any index concept. It is just key and value. Okay. So there is no need to
Ma'am,
compare.
Can we have a value in terms of list?
Yeah, you can have value can be anything. Okay. Value can be anything. It can be in terms of a list, anything.
Okay, ma'am.
Again, we saw that in dictionaries, it is also possible that there are dictionaries within the dictionary, right? So basically, what is that like? So in this dictionary, let's say I have some dictionary D1. In this, I have one key called K1. Now against this K1, whatever value is stored, that is again stored in the form of another dictionary. So this value also has key value pairs, like K2 is to some value V1, then K3 is to some value V2. Okay. Then again, there is in the outer actual D1 dictionary, there is another key K2. I'm sorry, let's call this K4. Then against this, there is again another dictionary. So dictionaries can be anything. The main thing that we have to remember is that none of the keys should be repeated. Either, even if we're talking about the outer dictionary, even there the keys should not be repeated. And even if the values are in the form of a dictionary, there also the key value pairs should be unique. Okay. So I think this much information about dictionary is all right. Can we start now? Please mute.
Yes, ma'am.
আমি যখন গেলাম
Debashi Sarkar, please mute yourself.
Okay. So let's start with the questions. If you still have any doubts regarding dictionary when we are solving the questions, you can ask. Okay. So question 1 is saying, let L be a non-empty list of integers. Okay. And D is what? It is a non-empty dictionary and both are given below. So this is L. It contains 8 minus 4, 10, 4 minus 6. And this is the dictionary D. Now, what kind of dictionary is this? It is a dictionary within a dictionary. So the actual dictionary D, it only has one. Correct. It only has one key value pair. One is to this dictionary. And again, within this in a dictionary, there are 3 key value pairs. What are the keys? Name, age, and gender. So it is saying match the following expressions on the left-hand side with appropriate values on the right-hand side. Okay.
Ma'am, what is one in D?
D is a dictionary. It is a nested dictionary.
Ma'am, there is one in bracket.
1 is the key. Okay. 1 is the key of this outer dictionary D. Now against this 1, there is some value. Dictionary entries are like keys to value, right? So this 1 is the key and this whole dictionary is the value. So it is a dictionary within a dictionary, nested. Again, within this nested dictionary, what are the keys? Name is the key, John is the value, age is the key, 12 is the value. Again, gender is key and M is value. Okay. So now you just have, this is very simple question, just have to do a match the following. So first option, you tell me member L comma 10. So which option from the right hand side looks the most appropriate? So is
True.
L, is
True.
10 a member
True.
of L? Yes, 10 is a
True.
member of L. So
Number 5.
A will
True.
be linked to 5. Okay. Next is key D name. Is name a key of the dictionary D?
No,
False.
false. False.
False.
So this should be false. Just a second. I'm getting a call.
Excuse me, is there anything problem?
Yeah, okay. So this one is false, right?
Ma'am?
Yeah.
Since we said the dictionary, in dictionary, random access is possible. So if you wanted to access the value of the key name, then how would we write it?
Then you have to write D. Then what is the outer key? 1. And then for name, if you want to find the name John, then you have to write the inner key, then name. Okay.
Okay.
Like that.
Yes, ma'am. Got it. Thank you.
Okay, next is C, D1 and age. So this should give me what? The actual value of the age, that is 12. So this is 1. Then first of L and last of init of L. First of all, tell me what is first of L? 8. What is init of L? Init means? Last one, we will
No, the
eliminate,
last
that is
one.
just minus minus 6 we will eliminate. And then take last of that. That means 4 is the last element.
4.
So this should be 12. Right?
Yeah. This is number 1.
Ma'am, please explain last in init L, please again.
See, what is init? What does init do? If I take init of a list, that means it will eliminate the last element in the list and give me back the rest of the list. So if I do init of this list, then it will take out minus 6 and give me this part of the list back, this much. Then from here, I want to find last. So what is the last of this list? 4. Okay. So 8 plus 4 is 12. So this one also goes to number 1.
Okay, ma'am, got it.
Yeah.
And ma'am,
Next.
if we are solving this kind of nested functions, then we have to solve the inner function first and then the outer function. Is this?
Yes. First do the inner function, then the outer one.
Ma'am,
The next, yeah.
in B, name is a key in one dictionary. Is it right?
Yes, let me see once.
Is in dictionary 1, name is a key. is key 1 comma name will be true na?
See, first of all, this is okay. This is B, right? Yeah, B should go to 4. That's why it is false, no? See, name is not a key in the dictionary D. It is a key in the dictionary, this one, in a dictionary, this dictionary. Okay. If I want to find the keys of dictionary D, then 1 is the only key.
Okay.
Understood?
Ma'am is
Okay.
asking if inside is key, it would have been 1 comma name. Like
Yes.
if name is a key of
Yeah.
1, then
Yeah,
it would
then
be
it is a key of that. Yeah.
Okay.
But here,
Okay.
if I want to find D's key, then if I wrote D comma 1, then it will be true. Okay.
Hello, ma'am.
Yeah.
For that B section, that is key, for that to be true, what should be right?
1 should be here.
And then the comma name.
No.
Bracket,
If you want to find the key of dictionary D,
Okay.
then is key checks what are the keys of a certain dictionary, na? So
Yeah, yeah.
is key D1 means is 1 is a key of dictionary D. Then it is true, 1 is the key. But name is not a key of this dictionary. Name is a key of this inner dictionary, right? And we don't have a name for it.
Okay.
We don't have a name for this dictionary, so maybe we can call it by 1 since it is the corresponding value to this 1 key. Okay.
Okay. Okay. Thanks.
Okay. Now in this one, first of all, you have to do rest of L. Okay. Rest of L, taking L as the whatever is given in the question, not after this D. Okay. So what is rest of L?
-4 to -6.
Minus
It
4
will be 10.
to this, right?
-6.
Yeah.
Then again rest of this means just this much. Then first of this is what? 10.
10.
So it should go to number 2.
Yeah.
Next, keys of D.
1.
1.
1.
List of 1.
So it should give me number 3.
3.
Right? Why is it in a list format? Because whenever we use the keys function, then the keys will come in a list format, right?
Yeah.
So none of them are actually the invalid expression. So which option will be here?
Option
Yeah.
B.
Please
One by
explain
one.
the D option first.
Which option?
D option. First L plus last initial and L. Can you explain that one?
What is first of L? First element in L.
8.
This is L. So first
Yes.
element is 8.
Yes.
Then in last of init of L. So here I have to do the inner function first, which is init of L. Init means just eliminate the last one. Eliminate this. So the rest of it is
4.
this. And then last of that. What is the last of
Is
this
4.
list? 4.
4.
So 8 plus 4.
ma'am. Got it.
So which option will be
Ma'am,
correct here?
Ma'am,
I want to ask one thing, ma'am.
ma'am, can you please explain
Ma'am,
keys of D, why it will written as a list, ma'am?
That is what
Yes,
the keys function does. Whenever you want to find the keys of a certain dictionary, you use the keys function. So here D is the dictionary. So keys of D will give me a list of keys of the dictionary D. But here D only has one key. 1. There are no other
I
keys.
know that. Yeah.
So that's why it is in the form of a
ma'am,
list.
I want
That's
to
it.
know
So-
that why it's written in the square bracket, ma'am.
That is how you represent a list, no? List is
Okay,
represented by square
Means,
brackets.
we will write in the list form.
Yeah, the keys will come in the form of list. If D had more keys, then 1, 2, whatever it is.
Okay.
Ma'am,
Okay, anything else?
ma'am, I have a question.
Hmm.
Yeah, in B, if we have is key of D, uh, D of list 1, comma name, will that be true?
Like, how do you want it to write? Keys of?
Is key of D within that list of 1, I mean,
Like this.
D list of 1, comma name.
Yeah. Now here, if you write name, then it's true.
Okay.
Ma'am, I want to know one, ma'am.
यही तो मैं जरा समझ में नहीं आ रहा.
As you have written, ma'am, D1 name in a list form. So if I want to add age in it, so I will write name comma age, or I will again use another square bracket.
I think
What do you want to do?
Ma'am, actually I want to find the age also. I want to add the age also there.
Yeah, then you
So
just
now-
write like this in option C. D1 age.
Okay, with name. Means a name also in a square bracket. After the separate, we'll use age as
You can only find one key at a time. No? So if you want to find the name, then instead of age, write name here. If you want to find age, then write age here.
Okay, ma'am. Okay. Got it now.
Okay. So option B will be the correct option here. You can match it.
Ma'am, can I
Next
ask
question is,
ma'am, it's just like normal. No, it's not in that question. It's just that the first and last, it may or may not return as a list, whereas rest and init always returns as a list.
yes, first and last will give you just the elements. Okay. First of a list will give you the first element of a list. But if you do rest of the list, then it just takes out one element. No, it just takes out the first element, but rest of the list it will return to you.
No, not that, ma'am. It's just that first and last, it may return the element as a list or like as an integer.
So it will just return the element itself,
Okay.
not as a list.
But rest and init, they always return a list.
Yeah, because they're returning the list now. They're just taking out one element. They're returning the list actual.
Okay.
Okay, see. Second question is, what will be the value of outlist at the end of the pseudocode? So this is n. N is a list of numbers from 1 to 50. Okay. Then A is a variable where I have assigned whatever is returned by this function sum list. Okay. Sum list procedure is defined here. But what am I passing as argument? This n list. So as soon as I call sum list here, my execution will come to line 13. So what is this doing here? So this x here is actually n. Okay, because we passed n as argument. So within the procedure, we have one thing called out list, which is an empty list initially. Then we have a variable called new list, which is x, where I'm storing x. So basically here I'll be storing the list n. So while length of new list is greater than 0. Okay, that means while length of n is greater than 0, in out list, we will append the first element of new list in the form of a list. Okay, whenever we are appending to a list, we have to append like this, right? In the form of a list. Then new list is equal to rest of new list. So let's just run this, what this will give. I'll just do 1 or 2 iterations. See, if I pass n here, then out list is initially empty, new list is n. Now, for the first iteration of this procedure, what is the length of new list? 50.
50.
So length of n is greater than 0 because 50 is greater than 0. So I will enter this while block, right? Then in out list, I'm going to append. Out list is initially empty. I have to append the first element from n. What is the first element? 1.
1.
So out list now looks like this. Then
Yes,
new
ma'am.
list was initially what? N. That is the list that we passed as argument. Now in new list, I'm storing rest of new list, then again the rest. That is 2 times the rest function. What will it do?
From
it will
3
just
to
take out the
50.
first 2 elements.
Yes.
So it
To
will now
50.
store 3, 4, 2, ... 50. So the
Ma'am,
first 2 elements are taken out.
Ma'am, outlist should be as a list of lists because it already is initialized as a list.
Out list is initialized as list. One
So it should
second.
be another list bracket. No?
No.
No.
No, we are
No.
adding to list.
We are adding the element to it. Na? This is how you add elements to a list. Whenever you append an element, you have to append it in the form of a list. But within the list itself, it will just be an element. Okay, this is just the syntax. See, after the first iteration, this is what we have. Now when I go to the second iteration, now what is the length of new list?
48.
48,
48.
which is a
Yes.
Madam, you are muted.
So, out with
then in new list, again do the rest of this. So
5 to 50.
5 to
5.
50. That means first 4 elements are taken out. Right.
So out
So
list
like
is
this
all
I
odd
will
numbers.
continue. Yeah. So
All odd
like
numbers.
this I will
Yes.
continue, and at the end of execution of this while loop, out list will contain just the odd numbers. Correct.
Yes, ma'am.
Okay. Now let's come back to the original question here. So
Ma'am,
once this is
could
done,
you please explain the second iteration again? I'm so sorry. Could you please
no
explain
problem.
that
See,
again?
up to this, length of n was 48, right? After the first iteration, since the first 2 elements are taken out. Now
Yes.
length of n is 48. Now it is saying if 48 is greater than 0, which is true, then I will again do the same thing. That is, in out list, I'm going to append the first of the new list. So what is new list right now? New list is nothing but n. And n is now starting from 3. Right? So the first element of n is 3. So this element I will add to out list. Okay. And then again, new list, I will take again the first 2 elements out. This new list is nothing but n. Okay.
Okay, ma'am.
So this way it will continue until the length of new list becomes 0. There is no more elements are present. So at the end, out list will contain just the odd numbers between 1 and 50. Right. If you do 2,
Yes,
3
ma'am.
more iterations, then you can see. Okay. So now back to the original code. It is saying
Excuse me,
after.
ma'am, one general dot. Hello, ma'am. One general dot. This lecture has been recorded format, no?
Yeah, it's recorded.
Okay.
Available on YouTube.
See, A will then store what? This list of odd numbers, right? This is what is returned. See, return out list. Then B stores sum list, rest of n. Okay. So remember one thing here, when I'm calling this n is the original n, this one, right? No
Yes.
changes has been made
Yes,
here.
ma'am.
This was just passed as an argument here. So again, I'm calling this function and passing this whole thing as an argument, rest of n. So basically, I am passing the list from 3 to 50.
Yes.
Right. I'm passing the list from 3 to 50. So rest of n will take out these first 2 elements. Na? So this much of will be passed in argument for this sum list, rest of n. So if I do that here, then if in this procedure only, then the first iteration, length of n is what? 48 again. In the
Yes.
first iteration only, length of n will be 48, no?
Yeah.
Yes.
Which is greater than 0. So now again in out list, we are going to store. See, out list is again initialized as empty. Okay. So this is a new
Yes.
list now. So out list will store what? First of
3.
new list. First
3.
is
3.
3.
Okay. Then again, new list is containing what?
5 to 50.
5
Rest of new list. That means 3 and 4 are now taken out. So now it is from here.
5 to 50.
So 5 to 50. Again, now what is the length? 46.
Yes.
Right.
Yes, ma'am.
46 is the length. So in the second iteration when I go, so 46 greater than 0, yes. So out list will contain again first of it, that is, now it is 3, 5, right? And
Yes.
new list is 7 to 50.
Ma'am, one
So
will
what is
not be
this doing?
out list.
What?
Ma'am, one will be included or not in out list?
No, 1 will not be included. Na? See, here you are passing this as the parameter. So 1 and 2 are being taken out here only. Okay. So after the iterations complete for this one, I will have the exact same list like we got previously. Instead of starting from 1, it starts from 3. So all the odd elements starting from 3. Correct.
Yes.
So that is stored in B. Now line 4 says, now I am initializing this out list as an empty list here. So for each y in A and for each z in B, so this is nested for, right? So for each y in A means it will start from where?
1.
1. So for the first y in A is 1. And for each z in B, this will start where? 3.
3.
If they are equal, then I will add it to outlist. So
Yeah.
how many elements are going to be common?
3 to
Everything
50.
except 1.
Except one.
All the odd elements between 1 and 50 except 1. Correct?
Yeah. Yes, ma'am. Yes, ma'am.
So which option?
Option number
D. Option D.
This is correct.
D.
Understood everyone? Any
Yes.
doubt in this?
Yes,
No,
ma'am.
ma'am.
Understood.
I didn't understand. Please explain once more.
No any doubt in this question.
Ma'am, can you please explain once?
The last portion
Which
only.
part?
Last.
How much did you understand?
Till B of some list is rest of L. That I understood after that.
Madam,
Up
here
to this you have understood, right? What is B returned?
Yeah,
Ma'am,
yeah.
But
I
what
have
is B
joined yet.
containing?
Please explain me again.
No. Madam, this will be
Just see,
wasting
if
a
I
lot
keep
of time.
doing this now, it will waste a lot of time. I don't have that much time.
Yes,
Okay, you do
ma'am.
one thing. Just check out the lecture once it is done. If you don't understand, then you can write to me. Okay, on my mail also you can send me. I will give you the solution again.
You can also watch in a
Or you
Madam,
can go to
from that
YouTube
second,
and
Yeah, that's what I'm
see the
saying. Just
live.
watch the recording. Just watch the recording after the class is over. Okay.
hello.
Or if I
Ma'am.
have time at the end, I will take this again. But first, let me go through all the questions once.
Ma'am, this today's session you will be solving only questions, or else you will teach the concept also, ma'am. Division.
In this session, I'm just going to do the mock questions. So there are 14 questions in mock.
Yes, ma'am.
Okay. Okay. Let's not waste time. So in this, see, this is a very interesting question. Two trains are called opposite trains if they stop at the same set of stations, but in reverse order, right? So if I'm going from Kolkata to Chennai, okay. Then whatever stops come in between, let's say I pass stations A, B, C, D in this order, and then I reach Chennai, okay. And my train number is maybe 12258. Okay, this train starts from Kolkata, goes to station A, B, C, D, then reaches Chennai. Now, what is the exact opposite train of this? Let's say there is some train 12005, which comes from Chennai to Kolkata. Okay, and passes these exact stations, but in reverse order. That means first D, then C, then B, then A, then Kolkata. Okay, if this is the route, then I can say that these two trains are opposite of each other. Okay, so it is saying is opposite is a procedure which takes these two trains as argument. N1 and N2 are the train numbers. Okay, and this procedure will return true only if these trains are opposite of each other in this respect. That is, they pass the exact same stations but in reverse order. So trains is a dictionary with train number as key mapped to a list of stations. So we have one dictionary called trains where keys are what? Train numbers, because train numbers are all unique. And each train number is mapped to the list of stations through which it runs. Like if for this train I made a key in my dictionary trains, it will look like trains 12258. This is my key. And what is the value pair? It is the list of stations that I'm passing. That is Kolkata, then A, B, C, D, then Chennai. Correct. So this is how each entry in the dictionary looks like, trains dictionary. Now in this example, the train with train number 12281 starts from Bhubaneswar and reaches New Delhi via Balasore, Adra, I think this should be Agra, Varanasi and Kanpur. Okay. This is the exact order that it is following. So we have to choose the correct code fragment to complete the procedure so that it returns the correct, it gives us the correct answer. Okay, we have to make sure that the procedure code is correct. You know what is the goal of the procedure. Now let's fill up the blank code from line 11. So what is the procedure doing? First of all, line 1, passing N1 and N2, the two train numbers that I want to check whether they are opposites of each other or not. So L1 is what? Trains N1. Trains N1 will give me what? Trains
Number
is the
of
dictionary.
station. Number of station passes through the.
Not number of stations. It will give me N1 is what? N1 is a
No.
key of trains dictionary, right?
Yeah.
So it will give me the value that is stored against N1. What
Yeah,
value
yeah.
is stored against N1? It is a list that
List
contains
of
all the stations that it passes. Okay. So if these N1 and N2 are, if these two are opposites of each other, then the lists that I get in L1 and L2 should contain the exact same elements but in reverse order, correct?
Yes, ma'am.
Ma'am,
Yes.
N1 denotes all the stations.
Read the question carefully. What is it saying? I just said that in trains dictionary, the train number is the key. And what is the value? It is the list of stations that train passes through. So if the train goes from Kolkata to Chennai, passing stations A, B, C, D, then the list will look like Kolkata, then A, B, C, D, then Chennai. Okay. So if two trains N1 and N2 are opposites of each other, then if N1 goes from station A to station E, passing station B, C, D. Okay. So this will return what? L1 will contain A, B, C, D, E in this order. And N2 is, say, a train which goes from E to A in the exact reverse order. So this will contain this. Correct.
Yes, ma'am.
Yeah.
If they're opposites, then this is what it should be like. But I don't know if they're opposites yet. Okay. So I just have two random trains and I just have created a list of their stations in L1 and L2. Now, if length of L1 and length of L2 do not match, then
False.
is there any chance that they can be opposite?
No.
No, ma'am.
No, right? Because they have to contain the exact same elements, just the order is different. So if one contains 5 station, one contains 4 station, we can easily say that they are definitely not opposites. So it will then only it will end the procedure and return false. But if the length matches, then it will come to line 7. While L1 is not an empty list. So as long as L1 list runs out of elements, I will run this while loop. So while L1 is non-empty and first of L1 is equal to last of L2. So just like this example, see, here first of L1 was A. It matches with which element? Last of L2. This is what reverse opposite trains should do, right? It should match in the reverse order. If first station should match with the last station here, then second station here should match with the second last station here. So that is what we are checking in this loop. Okay. So when I come to this loop for the first iteration, L1 has, let's say, in my example, these two are the lists. So L1 is non-empty. First of L1 is A. Is it matching with last of L2? Yes. Both are A.
Yes.
So then I will enter this while block and see what it is doing. L1 is now rest of L1. So eliminate the first element because I have compared it. So now L1 is B, C, D, E. And L2 is init of L2 because last element I have compared, so we can remove it. It is E, D, C, B. Okay. Now you go for the next iteration. Is L1 empty yet? No, it has 4 elements. What is first of L1 now?
B.
B. And what is last of L2?
B.
B.
B. So in this case, if the trains are opposite of each other, then this will always be true,
Yes.
right? Until this L1 becomes what? Empty. Until this becomes empty, this will continue iterating. Once it is empty, it will come to this line 11. Now we have to fill in this code. Now
Ma'am,
look at the options.
whenever L1 is empty, then L2 also empty, na?
See, that is what we are checking if
they are
one
opposite.
second. Yeah. If they're opposite only, yes. See, that is being checked here. The number of stations is being checked in line 4 only. Okay. So here we have to put a stop condition, na? Whenever we have a loop, it should have a stop condition also. Otherwise, it will be an infinite loop.
I mean, it stops under 2 conditions when it is not empty. I mean, when it is empty and
Yeah. When it is empty, it will stop. And again, if it doesn't find a match,
yeah,
it can happen that 2 stations, see, L1 may have A, B, C, D, E, and then here it may have E, D, C, but some P is there, and then A. Then what will happen? This first iteration goes fine because A and A are matched. Then this becomes rest, this becomes init. Then when you try to match the second element, B and P, they do not match. So this condition is broken. So it will break out of the loop, right?
Yes.
Once any of these conditions becomes false, it will break out of the loop. Now, what is the suitable code that I can fill in from line 11? Now look at the options. What is the first option giving?
Option 1 and 4.
This is an MSQ. Yes, I don't know what is the answer. I haven't
and
checked.
three.
So
2 and 3.
let's instead of saying the answers, let's just say how it is solved. Okay. So if L1 is empty, then return true. Else return false. That is, after this iteration is done, after this while block is done, if I see that the length of L1 is empty, that is L1 doesn't have any more elements left, I have checked all the elements in L1, then I can surely say that yes, it is true. These two trains are opposite, because for every element, then this condition must have been true. Correct?
Yes.
But if it is not true, if L1 is not empty, that is L1 still has some elements left, like in this example that I gave here, the iteration will stop after the first element only, because this condition is violated. So when it comes to line 11, it will check, is length of L1 empty? No, it still has 4 elements. So that means it will go to the else part and return false. So A is one of the answers. Okay. What is B? B is just, you can just see and say that it's wrong, because it's just wrong.
What about L2?
L2 you don't need to check. No, any one of them if you check, gives the same thing. See, you have to check L1 only. Why? Because here we are taking L1 as the condition. Okay.
But ma'am, it's not equally same distance. L2 have
No.
some.
L1, see, why am I checking this L1 is empty or not? Because some cases might happen like this example I took, na? That the first condition is okay, L1 is non-empty, but first of L1 and last of L2 don't match. Like here, B and P, they don't match. So
Ma'am, yes,
after the
I know
first iteration only, it will stop.
Ma'am, I want to know if there is same distance or not for returning. If there
Same
is,
distance.
yes, ma'am.
I'm not calculating distance here. No? I'm just checking if they're going through the same stations in reverse order.
Okay, ma'am. But ma'am, if we check for reverse order, it's not for destination.
I don't understand your question.
I mean, we have more elements, then it's not equal distance followed by L1.
B has more elements than, if L2 has more elements than L1, then it will be eliminated in line 4 only, no? Here I'm checking the length.
Okay, ma'am.
Okay.
We can check L1 or L2 to be empty because both lists are getting modified.
It is better to check with L1. Why? Because here I'm taking L1 as the condition. Na? So, see, this can happen. Actually, after this while loop, if you check L1 and L2, it will give the same result.
Yes.
Okay. If you check for L1 or L2, because even if one element is left in L1, then exactly one element should be left in L2 also. Right? Because that is how we are matching. If one element is left in L1, then I can say that for the rest of the 4 elements, I have found matches in L2. Okay. And see, after I find a match, I am reducing elements from both lists. So after this, you can check with both L1 and L2. Okay. It will give same result, but let's focus on what is given in the options. See. So this is wrong. See. In option C, it is already given what you are saying. That's why I have some patience when I go through the options. Okay, then I'll take all the questions. See, if L2 is empty, then return false. Is this correct?
Wrong.
No.
Same reasoning. If it is empty, that means it has found matches for all the stations. So it will return true. So option D is correct. So A and D are correct.
Okay.
Okay, everyone understood this question?
Yeah, last question. As you said, right, in the code we are not checking on L2, right? We are just checking on L1. So even though the option 4 is correct, but that condition is not getting checked in the pseudocode. Why we should say that it is a correct option? Because we are not, that condition is not getting executed in the pseudocode. Is that right?
No, it is.
Which condition? L2.
L2.
See, after this while, you can check for L1 or L2, it will give you the exact same result. Na? Here I have taken L1. whether L1 is non-empty, and then I am checking for these two. Here also, if you want to take if L2 is non-empty.
Got
Okay.
it. Got it. This
That
is
will also work.
after a while. Yeah. After a loop.
Yeah.
Oh, got
Yeah.
it. Got it.
Okay. Next is this. So again, let trains be a dictionary with train number as key mapped to list of stations with which that train runs through. So similar to the last one. In this example, the train with train number 12281 runs from Bhubaneswar to New Delhi via these stations. At the end of execution, code below L stores the names of stations through which the maximum number of trains pass. Okay. So now the question has changed to what? That at the end of execution of this pseudocode, list L should contain names of those stations through which the most number of trains have passed. That is, those stations which occur the maximum number of times in this trains dictionary. Correct? In trains dictionary, what happens? Every train N1 is mapped to the stations that it passes through. For N1 train, there are stations. For N2 train, there are stations. Like this, all the trains are there, right? So those stations which are present maximum number of times in these lists, those are the ones that we are looking for, right?
Yes.
Like if there are, say, only 4 trains. Okay. Some N3. Now, let's say A is present in N1, N2, and N3. That is, these 3 trains pass this station A at some point. And B is present in all 4. So which station am I looking for?
B.
A or B? B. Okay, this is the simple thing what this code is doing. Now let's break down the actual code. So stations is an empty dictionary first. Okay, in line 1. Then in line 2, N is assigned the value 0. N is a variable with assigned value 0. L is an empty list. This is the list where I want to store the names of those stations through which maximum trains have passed. So in this case, B should be stored in L. Okay. So for each X in keys of trains. So keys of trains is what? Train numbers. N1, N2, N3, N4, whatever numbers are there. Those are the keys. This is trains dictionary, right? This is the key. This is the whole thing is the value. So keys of trains will give me a list of train numbers. Now, for each of those keys, what you will do? Come to stations dictionary and update dictionary stations, X. That is whatever train number that you have picked. So what is this update dictionary procedure? It is maintained here. So if you are passing, let's say X is nothing but the first element in the, for the first iteration, I'm saying, keys of trains has given me a list of train numbers. So I've picked up the first train number. Let's say that is 12251. Okay, this is my X.
Ma'am, in this case,
And
X and Z are the same, no?
X and Z are same.
In every time we are
See,
checking the
parameter order is always maintained. Okay.
Okay.
Here stations, X means D is the stations dictionary and X is Z. Okay. So now come to update dictionary. So D is what? Stations dictionary. This is stations. This is X. Or in my example, 12251 number train. So for each A in trains Z will give me what? Trains of this 12251 will give me what? List of stations that this train passes through.
Name of the station.
Right? So maybe this train passes through these stations A, B, C, D, E. Okay. So this list I will get here. Now I have to traverse through this list. For each A in trains of Z. So what is the first element? A. If not is key D, A. What is this doing?
Checking
for the key
of the dictionary.
It is checking whether A is a key of that dictionary or not. Right? If it is not a key,
then add,
is it a key? Is it a key? First of all, tell me. In the stations dictionary, which is empty.
No, ma'am.
No.
It is not a key, right? Because it is empty initially. So I will create a key value pair. So D of A is 1. So in our example, this should be what? Oh, I have also taken A. Okay, that's fine. So D of A is 1. Else, if it is already a key, That means you are what?
Already.
Finding the
one.
station more than once,
Adding one.
right? That means finding the station more than once in other trains lists also.
Yes.
So if that is true, then you just keep on updating the value with incrementing it by 1. Okay.
Just a small query. The way to read this not is key of D of A is like not true, right? Like is key
Yes.
D of A
Is key will give true. Okay.
true,
See.
and then the way to read is not true, right? Then only you go
Yeah,
into the
not true. Yeah. And since this one will return false for the first iteration, since there are no keys, so this will return false. So not false is true. Therefore, you will create this key value pair.
Got it. Thank you. Just wanted to confirm. Yeah.
Yeah. Okay. So update dictionary procedure is, I hope, clear. What this will do is it will just update the stations dictionary in such a way. So stations dictionary will contain what? What are the keys of stations dictionary? The individual station names. A, B, C, D. These are the keys. And what are the value pairs? If
Number.
A is only passed by
Number
one
of
train.
trains passed to that station.
Yeah. So
It
let's
is
say
the
A
number.
is only passed by one train. So it will be A:1. Let's say 3 trains cross the station B. So B:3. 4 trains cross the station C. So C:4. Like this, stations dictionary will have key value pairs, right? And at the end, it will return the dictionary after all the iterations are done. Okay. So every time I pick up a train number from my keys of trains dictionary, I will do this procedure and it will update the stations dictionary. So at the end, station dictionary will contain keys as all the unique station names, and values will be the number of trains that pass through that station. Okay. Now, after this
Ma'am,
is done,
in this 1, 3, 4, these all will be in square brackets, right?
the key value pairs can be like this only. There is no need to put it in bracket unless you are assigning it as a list. These are just elements. No? If there are more than one values that I want to assign, then I can put it in the form of a list. This will just look like this only.
Okay,
Yeah, from
ma'am.
the
Okay.
code, it is not a list, no, because D of A is equal to 1 now.
Yeah, D of A is equal to 1. No? It's just a
It's not
single
a
value.
list.
Yeah. That's why we are able to perform mathematical operations. If it was a list, we won't be able to perform addition or subtraction like that. Okay. Then you come, after all of this is done, then you come to line 6. So for each Y in keys of stations. Now, what are the keys of stations? Unique station names. Correct? You have to fill in this part of the code. So let's take the options. What is the first option saying? First option is saying if stations of Y, that means what is stations Y? This is some key, right? Some key of stations.
A. Yes.
That is the first key, let's say. So A. If stations A is equal to N. Okay. N is what?
0.
N is what? N is initially 0. Right. And N was not updated anywhere. So
Yes.
if that station is not passed by any train, only then its value will be 0. That is, no train passes that station. If that is true,
Yes.
then it will store that in list L. Okay, that station name. Then in this line 4, you are checking if stations Y is greater than N. Okay, that is greater than 0. If it is greater than 0, then L will be what?
Y.
The Y station itself as a list.
Station name.
Station.
And N will be what? N equals to stations Y. That means whatever is the
Value
number of
trains passing
Number
through
of
trains that
trains
have
passing
passed through
through
that
that
station.
particular train.
Right. So 2 possibilities are there. One thing is,
Ma'am,
if we
I have a just question. Actually, fill the code. It's here. We are just passing through the key of the station and find out the maximum number.
our goal is to find those stations where maximum number of trains have passed.
Okay.
Okay. So it is saying that if initially, see, all of this is inside a for each block, right? So this iteration will continue as many times as there are unique number of stations. Correct. So for the first station, it picks A. Now, in my example, let's say no trains are passing through A. So A has what value assigned? 0. Is that possible? Tell me, is this possible?
No.
Because if there are any such stations where trains don't pass, then they will not be part of the station's dictionary at all. Right? See, because this key value pair is invalid, because whenever I'm creating a key in the station's dictionary, I am automatically assigning it the value 1. It starts from 1, right? So can there be any station which has the value 0
No,
in
ma'am.
station's
No.
dictionary?
No.
Not possible. So it will basically, this code is mainly for your confusion, because this will never happen. This is the main part. Here what happens, if stations Y, that means whatever station I'm picking, let's say I'm picking B. So what is the value of B? 3. Is 3 greater than N? N is initially 0. So yes, it is greater. So in L, I will take what?
B.
B as a list.
3
So
number.
L is now containing B.
Yes.
And in N, I will store what? The value. That is the
3.
maximum number of trains that
3.
have passed through B. So now N is 3.
Yes.
Now for the next station, when you are checking, let's say I'm picking up C now. Let's say I'm taking up C now. Okay. So what is the value of C? 4. N is now 3. So is 4 greater than 3? Yes.
Yes.
So now L is containing what?
C.
L is containing?
B and C. No, B, C.
Look carefully.
Only C.
Only
Only
C.
C.
Only C.
Only
Okay.
C.
Now see. Now N contains what?
4.
4. Now if I have one more station here, D, which is also passed by 4 trains, then what will happen? Because I need a list of all the stations. Then this first part of the code will come.
D.
Then this will come into play.
C
Now you come here. Is stations Y is equal to N. So for D station, what is the value? 4. And at this point, N is also 4. So 4 is equal to 4. So now in the list L, you will append D. So now L will look like C, comma D. Understood what is the importance of this part?
Yes, ma'am.
Yes,
So
ma'am.
for the first iteration, this part is not going to do anything. After that only you can do the comparison, because at first N is 0 and for no station I will have the value 0. Okay. So after the first iteration, this part will make sense. So is this code true or false? Is this the correct code?
True, ma'am.
It is
No,
correct code, ma'am.
No.
Anyone saying no?
Yes, I'm saying no. Because the possibility, suppose there is a E station with 5. Okay.
Okay.
And then what will happen is, then again the first order code will not execute. But in the second, it will append. It will not append. It will
But in
change the
second, is it appending?
value
It
to
is
5.
just going to assign that E.
Oh, assigning.
Just
Okay.
replacing,
Then
Yeah.
it's true.
C and D by E.
Yes, this is not going to append.
How to
This
hit-
is just see. This part is for finding stations that have higher N value. Okay, once you find a higher N value, you are going to
Correct.
abolish all the stations that you first took into L before that. Okay,
Got
and
it,
you are
got
just
it. I
going to
was
replace
where
with
to
that
eliminate-
station name.
Where to eliminate D, I was thinking. So it is getting eliminated in the
Yeah.
second automatically, because it's assigning
Yeah.
the value, not appending. Thank you.
Correct.
Thank you.
So this is correct option. Okay. This is an MCQ or MSQ. It's not written. I think this is an MCQ.
It's MCQ.
So do you need me to do the rest of the options, or should we go to the next question?
Can we check
Yeah,
one?
we may.
Any
Okay,
choice?
one more
So-
option. Let's check for B. Let's check B. So B is doing what? First, it is checking whether stations is greater than N or not. If it is greater, see, this is the wrong thing. If it is greater, if you append, right?
It will append
If
in
it is
descending
greater,
order. In ascending
Yeah.
order.
Because you are going to see. First of all, let's take that one example. Okay. So A is 1, B is 2, C 3, D 4. And let's say there is one station E 4. Okay, and then F 5. So it will, when it starts, N is 0. So for the first station A, 1 is greater than 0. So in L, it will append 1, A, right? Then N is containing what? Value of that. So what is the value corresponding to A? 1. Then it comes to line 5. Is stations Y equal to N? Is the value equal?
Yes.
It is equal. So it is again
Equal.
replacing A by A only here. Now go to the next iteration when I pick up B. So is 2 greater than 1? Yes. So in list L, it is doing what? It is going to append B as well. But these two have different n values. How are you appending them in the same list? This list should only have those stations which have the highest one, right? So you cannot append here. This part should be to eliminate whatever previous station names are stored, right? Append, if you need to do anything in append, then you have to do it in this part where I'm checking whether two stations have the same m value. So if they have, then I will do append. As soon as I find an n value for a station which is greater than the n value that we have seen till now, then I need to remove all the items from my L list. Na? So there should be no append here. So this is wrong.
Okay.
Okay. Rest of the two options are just variations of the first two. So you go through that. Let's come to this question. The following pseudocode is executed using shopping bills dataset. At the end of execution, count pairs should store the list. Count pairs is what? It is a list. It should store the list of triples in such a way that every triple has 2 items and the number of times both the items have been purchased together. Okay. For example, if milk and bread have been purchased together 3 times, then the triple would be like this. Okay. So what kind of elements are getting stored? It is storing list of triples. That is a list containing 3 things. What is that?
Items
Every
purchased,
triple.
number of items purchased together.
Yeah. So there will be 2 elements which are items in every triple and the number of times that both the items have been purchased together.
But both
Right.
that should be purchased at the same quantity, right? It cannot have milk is 2 and bread is 3. So it will not, it is not
No.
that triple.
Quantity is
Number
not
of times
in
they are
here.
purchased together. How
Yes,
many
quantity
in how
should be
many
same.
bills they have appeared together? Okay.
The quantity doesn't matter.
The quantity doesn't
Number
matter
of
here.
bills,
If
number of
milk and
bills.
bread are present in a single bill, then it will be counted.
Got it, got it. Thank you.
Okay. So for example, if milk and bread have been purchased together 3 times, then the triple would be milk, bread, 3. If purchased together 4 times, just change 3 to 4. Okay. So procedure get pair returns the list of pairs of items purchased in card X. So when I run this procedure for any shopping bills dataset card, it will return the list of pairs of items purchased in card X. For example, if milk and bread and sugar are present in card X, then get pairs will return all the possible pairings between these 3 items. Milk, bread, sugar, bread, sugar. These are the 3 possible pairs. So get pairs will give you all possible pairs of items that are bought. Understood? So if I had 4, then if I had milk, bread, sugar, and let's say something else, apple, then milk with apple, bread with apple, sugar with apple, then again milk with bread, bread with sugar, milk with sugar, all of the possible combinations.
It's possible.
Understood? Yeah. All of the possible pairings. Now it is saying choose the correct code fragments to complete the pseudocode. Okay. So what is this pseudocode doing? It is just executing everything that we read about here. Okay. This count pair, get pair, all of these things. Let's see. So count pair is doing what? List of triples
List of
such that
triples.
triple has 2 items and number of times both the items have been purchased together. So initially count pairs is what? It is a list, empty list. Okay. Now I have one more empty list called X pairs. I have one more empty list called pair list. Okay. So while pile 1 has more cards, pile 1 is nothing but your shopping bills data set. Read the top card from pile 1. Then in X pairs, you are calling which function? Get pairs, X. Okay. So get pairs should be here somewhere. Oh, okay. It is not given. Okay. So in X pairs, I'm going to store all possible pairings from that card, right? If that card has 4 elements, then all possible pairs of those 4 elements will be stored in X pairs. So X pairs is what kind of a list? List within a list. Correct.
Yes, ma'am.
Nested list.
Now, paired list has what? Paired list plus x pairs. So it is just appending all the x pairs. Okay, that you get. Then move x from pile 1 to pile 2. So let's say if I have the first card, if I have this milk, bread, and sugar. So x pairs will contain this, right? Correct. Now in pair list, I'm first going to append this. So it is now a list within a list within a list. Correct. Because paired list is itself a list. Now for the next card that I pick, I will again get all the possible pairings in x pairs and then append that to pair list. So pair list is nothing but a list of all the x pairs for every card.
X pairs means
Understood?
all the possible
And
pairs.
x pairs means all possible pairs of items that are bought in that card.
Okay.
Clear? Now line 9, check. Up to this everything is pretty simple. Then line 9, length of pair list is greater than 1 as long as pair list length is greater than 1. Rest list will be an empty list. First pair will be an empty list. Triple will be an empty list. Pair count is 0. See, a lot of variables are here. Okay, so just be a little mindful. Pair count is 0. Item 1 is none. Item 2 is none. Okay. Now this is all initialization for these two lines. Actual code will start from here. So first pair is a list, empty list. In that, I am going to store what? First of pair list. Okay. First of pair list is what?
Ma'am means first ordered pair, for example, milk and bread.
X pairs.
First element, ma'am.
First element in pair list.
First element in pair list. So
Can
first,
you take an example for this?
yeah, I'm going to see. See, for the first card, if I had this milk, bread, and sugar present in the first card, then x pair will be this, what is given here. This x pair only I am storing in pair list. Okay, so pair list is a list which is storing a list within a list. So there are actually 3 parts to this: list within a list within a list. So this is the first element of your pair list. Okay, milk, bread, milk, sugar, and bread, sugar. This is the first element of pair list. Now second element, maybe some other list has apple, milk, bread. Then apple, bread, milk, bread, and apple, bread. This is the second element of pair list. Like this, pair list elements will continue. Understood? So when here I say first pair contains first of pair list, so it will contain this element, this entire list from here to here. Okay. Then item 1 is equal to first of first pair. That means, what is the first of first pair? Milk and bread. The first list.
No, but first of first pair.
Yeah, so first pair is containing what? This entire list.
Yeah. Okay, got it.
Then first of this is the first element, milk, comma, bread. Right. Then item 1 is what? First of. Okay, item 1 I did. Item 1 is first of first pair. Item 2 is last of first pair. So this one, bread, comma, sugar. Okay. Now for each pair in rest pair list, when I do rest pair list, then I take this first item out. So it will start from here now. Okay. So for each pair in rest pair list, if first pair, okay, equal to item 1. So for each pair in rest pair list is giving what? It is starting from this element, right?
Yeah.
This is the first pair in pair list now after I did this rest function.
Yes, ma'am.
So if first pair, that is first of this is what? A comma B, this one, is equal to item 1 that we stored here. What was item 1? Milk, comma, bread. If they're equal, or if the last pair, that is, what is last pair?
Sugar.
A comma milk.
It is going to be, no, what is last pair?
You written AB, but it is
AM.
A, comma, milk.
M.
It should be AM.
This
AM.
one. A comma B. Okay. Oh, I have written this twice. Okay. This should be
A comma M.
A comma M. M,
Yes,
right?
yes.
Okay. So A comma M is going to be the last pair. Okay. So if that is equal to item 1. So if any of these are equal to item 1, item 1 is what? First of first pair, that is milk comma bread. If any of these are equal to that, then there is some missing code here. Else, it is saying rest list is equal to rest list plus plus pair. So rest list was initially what? Empty. Okay. And this will contain nothing but the pair that you are selecting in the for each block. So what did we select first? This.
Milk.
This thing. Right. This list. So if none of these conditions match, or will be false when both are false. That is, first pair is not equal to item 1, last pair is also not equal to item 1. If this happens, then you append this pair to rest list. Then, after all the iterations are done, you have to come here. Line 26, that is doing triple equals to item 1, comma item 2, comma pair count. Okay. So item 1 and item 2, these will all keep on changing, right, with each iteration of this while loop. And count pairs is what? Count pairs plus plus triple. So this triple thing is new here. Triple was just introduced as an empty dictionary here, empty list here. But it was never, we didn't work anything with triple, right? Forget about this part. We haven't done this yet. So whatever is in the triple list, that I will store in count pairs, and pair list will be rest list. Okay, now let's check where each block is ending. Okay, so that we don't make a mistake here. So this while ends here. Okay. This while is ending at the end. That means for each iteration of this while, this triple count pairs and pair list will be updated. Okay. Then this for each block is ending where? Here. This is the end of the else. This is the end of the if. Now we have to just find what is within this if. Okay. Okay. Now, it's better that we do this using some cards. Okay. So we have picked 2 cards. SV stores for Akshaya. These are the 3 items: curd, butter, milk. And for Julia, these are the 6 items. Now, line 4. Okay. Line 4 says X pairs stores the list of pairs of items purchased in card X. Let's go to the code. This is line 4. Line 4 says X pairs is get pairs. That means whatever card I'm picking, all the possible pairs I'm storing in X pairs. Right? So what will X pair do for the first card? Akshaya's card. Curd butter, curd milk, buttermilk. These are all the possible combinations. Right? Then line 5, this list of pairs gets appended in pair list. For the first time, pair list will be the list of pairs of items seen in first card. In example, in this example, pair list will be what? See, this whole list that we just found, right? Are we appending anything in pair list? Check.
But
In pair
initially it is
list,
0.
again, initially it was nothing. It was just an empty list. Then
Right.
after I read the first Akshaya's card, I appended that X pairs to this. But you have to check one thing. After this, when does it get appended again? When I pick up the next card. Till then, I don't touch pair list. Okay. So up to this is the pair list. Now again for the second card, X pairs is all of these because there are 6 elements. So of course there will be a lot of combinations of pairs. So now again, this list will get appended in pair list and pair list will become what? This. See, up to this, it had just curd butter, curd milk, buttermilk. Then all the other combinations also get appended. Right? But, okay, one thing I think I missed is that since here when we are solving appending things to paired list, we are appending normally, not in the form of a list. Okay, so all the pairs individually will get added.
Excuse me,
Okay.
ma'am.
Yeah.
Hello. Yeah, ma'am. In pair list is equal to pair list plus x pair. Will it be getting the getting pair x in that?
Yes, it will get all the pairs that are in X pairs at that point.
But then if
Okay.
it is not a list, then why we are using two plus signs? Isn't should be only one?
No, anything that you append to a list, it has to be appended by two plus signs only. But
Even if it
if
is a
you want
list
to
or even
append
if it is
this,
an element, right? This is what
yeah,
you're saying.
yeah.
Okay.
But if you want to append this as a list, then this will be like this. Okay. But that is not given. So it is just adding all the pairs from X pairs into pair list.
But madam, X pairs is already a list.
Yeah, it is a list. But see, when it is appended to pair list, only the elements are appended, not all the three elements in the form of a list. See, it is a list within a list only. Look, if this was in the form of a list, then curd butter, curd milk, and buttermilk, these three should be in a separate list within pair list also. But that's not the case. These are just appended as single elements.
Okay, so when we were solving, we made a mistake. Because earlier we said pair list is a list within a list within a list.
Yeah,
So
that's
there
what
is
I
three
thought, because
lists.
usually that's how we
Yeah.
append, but here that is not how they have appended. They have appended just the elements from X pair. Okay, so even after this Aksha's, after that Julia's card, all of these pairs that we generated in X pairs, they are all going to be added to pair list like this here.
Yeah, yes, ma'am, that is correct. We can have another example like with numbers so that it will make sense actually. Like,
Yeah, this is a complicated question. Okay, let's complete it anyway. So this means pair list is the list of pairs of items purchased together from the whole data set. Correct? This is very simple. See, every time we find a card, we are taking every possible pair in that card, right? That means items that are purchased together. Like in Aksha's card, butter, milk, and curd are purchased together. So each pair is formed of those items which are purchased together in a list. Correct? Like this curd butter or carrots milk, these are all from the same card only. They are purchased together by one customer. Yes or no?
No, not in the pair list.
So all
No,
all possible pairs we are making.
In this pair
Data
list,
sets.
okay, in this pair list, every pair that is there, like curd butter, curd milk, carrot cereal, it means that these two items have been purchased together. That's why they are in this list, right?
Yes.
Can you please show the like the example cards again? The cards that were given. Okay. Thank you.
Okay. So all of these items have been purchased together. That's why they're in this list. Now, count pair is supposed to store the triples. Okay. Count pair is supposed to store the triples. What are the triples? Two items that have been purchased together and the number of times that they have been purchased together. So, check here. Can you see anything that is getting repeated in this list? Curd milk is here, curd milk is here. Okay. Again, curd butter is here. It is, I think, somewhere else I also saw. Anyway, somewhere it is there, I guess. So there are repeated pairs also, right? Now see, it is saying to find the same pair, the usual procedure is taken. Only one problem is here, that the order of the items in pairs is not fixed. For example, bananas curd and curd bananas are pairs with same items with no respect to their pair of items, but bananas curd is not equal to curd bananas, right? Two lists which are having same elements in reverse order, are they equal lists? No. Right? So because of the ordering also, this type of two pairs, even though they are the same two elements from the same card, they are still not equal. Okay, therefore we need to check either the first item of the first pair is same as either the first or the second item of the second pair. So this thing is being checked where in the code? Here. Here I am checking that in this if block. That means I am taking these pairs and I'm checking each item with the first item as well as the last item, right? So this is to account for what? If there are such pairs like apple, bread and bread, apple. If these two pairs I get to compare, then if I compare them directly, it will give me that they're unequal, right? But actually these are same pairs. So that's why I am checking the first of this with the last of this and the last of first with the first of second list. Okay, that's why first pair is equal to item 1 or last pair is equal to item 1. If any of these are true. Now see, it is saying we need to check either the first item of first pair is same as either the first or the second item of the second pair. And same for the second item of the first pair should be checked. If matches for both, then increment the pair count. So in line 16, the first item of the first pair is being checked. If it is true, then the second item should be checked. So line 16 is where? This line. Okay. So if I have two pairs, so first item of first pair is being checked, right? If it is true, then the second item will be checked. If it is true, then second item should be checked. If the second item also matches, then pair count should be incremented. If it does not match, then pair count should not be appended to the rest list. Why am I doing this pair count? Anyone?
So that you get the total number.
For the triple.
Yeah.
For the triple. Because in the triple, I have to show that these two elements occurred together how many times, right? So that's why I need to maintain the count. See, I'll do this part one more time. In line 16, first item of the first pair. Okay, let's say this is the first pair, bananas and curd. So first item of first pair is being checked. If it is true. So what is item 1 here? See, first item of first pair, right? So now that is stored in item 1. After that, I am taking rest. After that, I am taking rest pair. That means the first item is now gone. So what am I checking with? The second items first. So this first pair is what? It is actually the first element of the second pair. That is being checked with item 1, right? If this matches or this matches, then I will come to this part. This part should contain what? See, after every run, rest list stores the pairs of items which are found to be mismatched with the pair of pair list. So all the mismatched items for which the item 1 and item 2 didn't match, none of them matched. There is an OR condition, right? It will be false when none of the conditions are true. That is, first pair is not item 1, not item 2. It is not matching with any of the items. Then triple stores the two items and the number of times these items have been purchased. And line 27 is this triple is being appended to the final list count pairs. It's a very complicated question. See.
Please share the PDF so that you can.
Yeah, it is given on the portal. It is uploaded. Okay. After, see in the mock quiz 2 part.
It is not.
After that, the solution is given. So triple is here storing all the triples with where the items have matched and the pair counts that I have maintained. Okay. And then count pairs is nothing but a list of such triples. And after that, from pair list, since I've checked the first two pairs now I'm going to do the rest list. Assign it the rest list. What is rest list? See, rest list is containing everything, every pair for which these conditions are false. That means none of the items match. Those are in rest list. Okay. So which code is correct here? Let's check the first option. If first pair is equal to item 2. Look, up to this, everything is clear, right? Here, what we are doing? first two pairs I'm comparing. Okay. First two pairs. Let's say the first two pairs are nothing but AB and BA. Okay. So what is the first pair? First of pair? Let's say this is the pair that I'm talking about. What is the first of this pair? A? Right?
Yes, ma'am. First of
Okay.
first
Let
pair, right?
me just take some better example. I don't want any confusion in this. Look. Initially, in pair list. Okay, from pair list, I'm picking the pairs. So let's say in pair list, the first element is A, comma B. Okay. And the second element is B, comma A. Clear? So when I pick for each pair in rest pair list means I am cutting this first element out. Now this is the first element, right? Rest of pair list.
Yes, ma'am.
Now, before that, item 1 and item 2 were already populated with what? First of first pair.
A and B.
And last of first pair. That means item 1 is A and item 2 is B. Then you are picking this pair B, comma A from rest pair list. Now in this if statement, what you are doing? First pair is equal to item 1. So first pair is what? B. Is it equal to A?
No.
No. But there is OR condition. So we'll check the next one too. Last pair is what? A. Is it equal to item 1? That is this A? Yes. So if one of the conditions satisfy, that means whole thing is true because this is OR condition. So now we will go into this OR if block. Now in this if block, now see, I have only checked for one element, item 1. I have to check for item 2 also. For two pairs to be exactly equal, I have to check for both the items to be equal, na?
Yes.
So after this, what I should check? That whether this B is equal to this B. Right? This I have to check. So what is the code for that? It is saying first pair is equal to item 2. That means again, what is first pair? B. And what is item 2? B. So if this is true, or last pair, that is A is equal to B. If any of these are true, then pair count will be increased by 1. That means I have found two such pairs of same things. Okay, same elements. Why am I doing all of this? Because if there are two pairs, AB and AB, then that also will be caught by this code. And if there are two pairs, AB and BA, that also will be caught by this code. I'll be able to identify that these are actually same pairs, right? That's why all of these comparisons we are doing. And if it is true, then only pair count is increased. What is this pair count being maintained for? The triples list, right? Where I'm going to show that, okay, these two items occur together, but how many times? That is coming from pair count. Else is rest list equals to rest list plus pair. So if it doesn't match, that is two pairs are not exactly the same, then they will go into rest list. Clear?
Yes, ma'am. Understood.
See, this is a very big problem. So just go through it twice or thrice. Okay, it might take some time. You just create some own examples. You can take any two cards and check. Main thing is, see, this part that we are being asked, this is actually the easiest part. Okay, all the hard code is actually given to you. This is the easiest part of comparing. So don't get confused between item and first pair, last pair. See, think of it like this. In my pair list is containing all possible combinations, correct? Because it is a addition of all the X pairs from all the cards. So it is all possible combinations from all cards. Now, just take the first two elements. Let's say the first element in pair list is AB. Now, in item 1, I'm going to store A. In item 2, I'm going to store B. After that, I am going to run a for each block, that is a loop, within rest of pair list. That is, I have now taken out what? This AB pair. I'm starting with the next pair. If the next pair is, say, BA, then you have to check every element of this with every element of this. That's why all this comparison. So once you are checking first and last of this pair, BA, with the item 1, which is A from the first pair, And again, within that, if any of these conditions are matching, that is, if any of the elements are matching, then you have to check for the second element to match also, if it is matching or not. That's why I am taking this. Now I'm just matching B and A with item 2, that is B, from the first pair. If these match, then pair count increases. That means these two pairs, these two have occurred together. Else, it will just add to the rest list. Just like here also, if the outer if only is wrong, okay, that means there can be a pair AB and there can be a pair CD. In that case, in the outer if only, this will become wrong. Tell me, what is the first, if this is the first element AB, item 1 is A, right? This is item 1. And this is the pair that I have picked to compare with. So what is the first of this pair, C? Is item 1 equal to C? No.
It's false.
But there is an OR, so I have to check both. So is item 1 equal to D? That also is wrong. So if both are wrong, then will I go into the nested if?
No.
No.
I will come to the else part and add it to rest list. So for every pair that is not matching, you just keep on adding it to rest list. And for every match that you find between two pairs, you are going to add the pair count by 1. Understood? This is the main logic here. So just go through the solution one more time. You can take any 2 cards. If there is any confusion, you can ask me. But this is the answer here. First, this. Why are the rest not the answer? What is the difference? See, here it is definitely wrong, you can tell, because I am never comparing the first element of second pair with the second element of first pair. This should be item 2. Right? Because for item 1, I have already checked in the outer if here. First pair is equal to item 1. Why am I going to check it again? Right? This should be item 2. So that's why this is wrong. Then again here, what is this? So last pair is item 2 and. So there should be no and.
Or.
This should be or. Because this and, if it satisfies this, it means that both items are same. Then it is not even a valid pair. Right? And here again and. So this is wrong. See, actual thing is very easy. If you actually look at the part of the code that you have to find. But understanding the question is the difficult part here.
You can discard the options by doing that.
Yeah, even you can discard the options, but for that also you have to know now what is pair list, what is first pair. You have to understand this part first. This rest list, pair count, all of these variables, what each represents. Then the actual code part is very easy. Yeah.
Ma'am, I have a doubt. Like, if you see the first pair is equal to, can you show me this? Like, first pair is equal to first of pair list. So the first of pair list should be Bill, B, MS and BS, right?
No, it is just one item. That's what I told. Na? See, here X pairs is being added to pair list. So it is not in the form of a list. These are just individual pairs that are added to pair list. Pair list looks like this. This is pair list. This one. See, just individual pairs. Okay. No list.
Okay, fine. Okay, thank you.
Okay. That's why this comparison we are able to do. If it was in the form of a list, then it will be even more complicated. You have to extract elements from every list and compare. Okay.
Yes, ma'am.
So next one. This is why mock is very important. See, if you can solve the mock question, your actual quiz 2 question will seem very easy. See, the given pseudocode is executed using the scores dataset. At the end of execution of given pseudocode, choose the correct options. This is an MSQ. Okay. So now this code looks like very easy after the last code. See, topper is what? In this topper variable, I am somewhere running this procedure find top with table 1 as the argument, and whatever is returned, I'm storing that in this topper variable. What is procedure find top doing? So procedure find top is defined here. Table 1. Okay. So the entire scores data set basically I'm passing as argument. Then inside this, there is a max variable which is assigned the value 0 and a top variable, which is basically an empty list. So while table 1 has more rows, that means while scores dataset has more cards in it. If, okay, you are going to read the first card. If x dot total is greater than max, max is initially 0. So whatever is the total, if it is greater than 0, then max will contain that total and top will contain the sequence number of that card, comma max. Okay, so top will contain this list, whatever is the current max and the sequence number of the card that you just saw. Only if the card's total is greater than max. Okay, let's take a little example like this. Let's say the first card is of sequence number 1. They have scored total of 200. Oh, 1 second. Yeah. So sequence number 1 card has scored total of 200. Sequence number 2 has scored total of 250. And sequence number 3 has scored total of 150, let's say. So these 3 cards I will run here. So when I read the first row, okay, what is the total that I read? 200. Is it greater than max in first iteration?
Yes, ma'am.
Yes, ma'am.
First iteration, 200 is greater than 0. Yes. So now max is what? 200.
200.
And top is what? Sequence number,
1.
comma max. That is 1, comma 200.
200.
Okay. So this if block is over. Now I can move this to table 2 and pick the next card. So second iteration. Now, what is the total? 250. Is 250 greater than max? That is 200? Yes. So now max becomes what? 250. And what is top? 2, comma
250.
250. Okay. Now again move it to table 2. Now come to the third iteration. What is the total? 150. Is it greater than max?
No.
Is 150 greater than 250?
No.
So none of these will happen. This if block will not execute. And I will simply move it to table 2. Let's say this is all the cards I had. Now, after this is done, after all the cards are exhausted, that is this while loop ends here. Move all rows from table 2 to table 1. That is all the cards that we saw. Move them back to table 1. And return top. So top will contain what?
One entity sequence number.
The sequence number and the sequence number and the total marks of the maximum total, right? Card which has the maximum total.
2,250.
So what are the options? Topper is a list of 2 elements. Is this correct?
Yes, ma'am.
Yes,
ma'am.
Topper is not appended. Okay. Topper is always replaced every time we find a different max. So topper is definitely a list of 2 items, sequence number and the greatest marks. B is first topper. First topper represents the sequence number of one of the students who have scored the highest total marks.
Yes, ma'am.
So it can happen that 2 students have scored the highest total, 250. It can happen. But what will the topper, what will topper contain? It has
Only one sequence number and only one of the marks.
So if I say that after this sequence number 3, there was some sequence number 4 who has also scored 250. So at that point, top will contain what? 4, 250, right? So basically the last person whose card I have seen that has scored the greatest marks, their sequence number will be stored.
No, madam, in line 6.
Oh, I'm sorry.
X total, if it increases, it is more than
The
max
first one.
only, then it will be replaced.
So the first one, right? Correct. The first card which I find which has scored the max, right? So after this, even if there is a 4 with 250 that comes, the update will not happen because this condition will fail. Very good. Okay. So first of topper represents sequence number of one of the students who has scored highest total marks. This is also true. What is option C? First topper. Yeah.
Excuse me, ma'am. Could you repeat the last part you just said? That is not update something.
Yeah, I said that. See, after this third card, if I had one more card with sequence number 4 who has scored 250.
Right.
Okay. So after seeing this third card, at this point, what is max? 250 only. Right. So is 250 greater than 250? This is wrong.
Okay. Got it.
So that
Got it.
sequence number will not be updated. So it will just contain the sequence number of that person who has scored the highest marks, highest total marks, and whose card comes first.
Correct. Got it.
Okay.
Before a card comes in, which is of a lower mark, and then nothing gets updated because.
Right.
Okay.
Yeah.
Just the language English, for example, in the B, it says first topper, it includes the student name. That's okay. But it also includes comma marks, right? Which is not part of the
First of topper. First of topper. What is first
of topper?
returning? Only the first item, which is the sequence number. Okay.
Ma'am, if the mark is 250 is greater than or equal to max.
Yeah, then it will take the last card who has scored the highest marks.
Only one highest topper will be taken.
Yes, it will only take the only one pair because it is not getting appended, it's getting replaced.
Okay.
Every time I find a person with the highest marks. Okay. So if there was an equal to sign, then yes, it will take the last card with the highest marks.
And in fact, that is the reason they have used the term one of the student, because there might be multiple students having the same number.
Correct. Exactly.
It is not the student, it is one of the students.
No, it is one of the students because many students can have the same total. Now, third option is what? First topper is the list of sequence number. Now, there is no chance of it being a list because again, we are not appending, right? It is just one single sequence number. So this is wrong.
In this problem.
And last of topper is the highest total mark from table 1. This is correct. So A, B, D are your answers. Is this understood?
Yes, ma'am.
Yes, ma'am.
Okay, good. Now question 7. Consider the procedure find top mentioned in the previous question only. This is find top, the name of this. Okay, yeah. The following pseudocode is executed using scores dataset. Let remove row table comma z deletes the row. This remove row table comma z is another procedure. Okay. What it does, it deletes the row of table with sequence number z. So whichever card is having sequence number z, for that it will delete the row. What will marks list represent at the end of execution? So topper is an empty list. Marks list is also an empty list. While table 1 has more rows, that means the scores data set. Topper is equal to find top table 1, right? So this find top procedure is going to return what? Sequence number and total of the student with the highest total, correct?
Yes.
First student with the highest total. After this, it is saying remove row. Okay, remove row table 1 comma first topper. So what is this doing? It is going to remove the row of the sequence number that is stored in this topper. That is this sequence number. For this sequence number, it will remove the entire row from the table. Understood? So if in our example, who was the person with the highest marks? Number 2 with 250. Right. So topper is having this stored, this line. Then I do remove row table 1 comma first of topper, that is 2. So this row is getting removed from the scores dataset itself. Understood?
Yeah.
So what will marks list represent? Marks list is what? Marks list plus topper in the form of a list. So what is this now? Think about it. I will not give you the answer right now. Just think about it a little. See the options. I'll give you the options. Okay, then you cannot see the code. Have you seen the code or do I give you the options? See.
Option 2, list of sequence numbers in descending order.
Descending order based on the total mark.
You're saying list of sequence number in descending order.
Option C.
C option.
It's option C.
Option
C.
See clearly. Option C, it should be correct, na? Because it is appending what? The topper list, which contains both sequence number and total. You are getting confused because this remove row, we focused on sequence number. So it is not deleting the sequence number from topper. It is deleting that row from table 1. Okay.
Okay. Yeah.
So topper list is still a list of sequence number and total.
So
But
entire
in
book,
which order will it be?
Descending order.
Why descending?
The first who got first comes first.
Because in our
The
find
rows
topper,
removed from the
we
top.
were finding the
Because
maximum
after
one.
correct, because after I delete this, then topper will contain the next sequence number with that total, right?
Yes.
What if you have 3-4 element which are the same number, like 250 example that we have taken, and assume that that list doesn't have any other lesser number? What the function will do in that case?
So if all of them have scored the same total.
I mean, assume that in the example that you've taken, right, your fourth element D was 250, right? Now it deleted the one in the table. Next time, the next 250 row will come.
If I
after
took my
150.
example, in this, then what will happen? See, table 1 has more rows. So I picked up the first table 1 has more rows. So topper is find top table 1. Okay. So what is topper containing right now? This 2,250. Then I did remove row.
Yes.
So from table 1, that is from my scores dataset, I'm removing the row for this.
Correct.
And then in marks list, I'm appending the topper as in the form of a list.
Correct.
Okay. So this will contain this 2,250, right?
Yes.
Because topper is still that.
Yes.
Then in the next iteration, what will happen? When I search again, I will not find this in the list at all because this is now removed.
Yeah.
So it will take the next one.
Which is 150. Yeah.
So that's why it will be on descending order.
No, but you have a D element which is 250 again, right?
Okay, see this.
That's what
I understood. See. From the
first,
previous question, we know that procedure topper will store the sequence number and highest total of one student, right? In the given pseudocode, after finding the sequence number of one student who got highest total marks, it is removed from table 1 by this remove row. Then topper as a list is appended to another list called marks list. And this process continues till table 1 has no rows left. Okay. So even if I find another person with 250, it will add to your marks list.
But
Okay.
it will add
You
that
have become
sequence
the
number
new
also,
topper.
right? The difference will be sequence number then.
Yeah, the difference will be the sequence number. And once it adds, it is going to delete it from the scores dataset from table 1. And then
You have
again
only
go for the next one.
Yeah.
So of course, it is always going to find the next highest, like this it will go. So it is in a descending order. So the last element that it adds to marks list is the person with the lowest marks. Understood?
But you are saying it will delete from the mark list or it will append?
It is deleting. It is in marks list, it is appending. But in table 1, that is scores dataset, it is deleting the highest.
That's fine. Assume that you will have A and D entry of 250 in the mark list, right? Correct. You will have two entries in the mark list because they are 250.
Yeah, then
Will
both of them
still call it a
both of
descending
them
order?
will come.
No, but will you still call it a descending? Because then you will have.
See, no.
Most
See,
of them are-
then there are actually this thing in math is there. So a list can have this is also descending. Okay, 5, 4, 3, 2, 1. This is descending order, right?
Yes.
And if there are similar elements, then for it to be in descending order, it should be like this. This is also descending, but with duplicates. Okay. This is also descending, but with duplicates. So this is what is going to happen here. Yeah. So the last element that comes into the list is going to be the person having the lowest total marks. Agreed or not?
Yes.
Even if anyone doesn't agree, you can speak up. Okay.
Ma'am, like I understood the gist of it, but I'm a bit confused when it comes to the pseudocode. Like, are we again and again calling the procedure find top for each
we are
and
actually
every
calling.
row?
Yes, correct. We are going to call this topper procedure till table 1 has no more rows present. So every time we call the topper procedure, one row gets removed from table 1. That is the one having the maximum marks. Okay.
Yes, ma'am, got it.
Okay. This is a very simple question, but this thing you haven't seen. No, that's why you're getting confused, because every time we used a while, we always said read top card from this table. But that statement is not here. Why? Because here the entire table is the argument, not a single card.
Yes, ma'am.
But every time the argument changes because one row is getting deleted from table 1. Clear?
Yes, ma'am, got it.
See, question 8 is consider marks list that we created in the last question. What will top list represent at the end of execution? Okay, so these three questions are related. So marks list was what? List of sequence numbers and total marks. List of sequence numbers and total marks in descending order. Right?
Yes, ma'am.
Now, top list is an empty list. Counter is a variable which has 1 stored in it initially. Max is equal to last of first of mark list. Okay. Tell me, what is first of marks list? The first person having the highest total marks. He was first added to marks list. Right?
Yes.
Descending
Yes, ma'am.
order. And then I'm going to find the last of that, which is the actual total marks that that person scored. Right? This is the pair, let's say. In our example, this should be the first of mark list. Correct?
Yeah.
What is the last of this thing? 250.
250.
That is the marks that is actually scored. This is stored in max variable. Now, for each pair in marks list, if last of the pair is not equal to max, that is for each such pair, sequence number and marks pair, if the last, that is if the marks is not equal to max, then max is going to be that mark. Okay. So how is this working? Now marks list is in descending order. After this, let's say there is a card of some person, like in marks list, after this, say there is a card of some person with, in our example, there is one more person with 250, right? So this is the next card that is in marks list. Okay. So what is the last of this card? Again, 250. Is it equal to max?
Yes.
It
Yes,
is
ma'am.
equal. So this condition is false. So this if block will not be executed. This if block. Okay. Instead, I will go to the line 8. If counter is less than 4, counter was initially 1. So yeah, it is less than 4. So top list equals to top list plus first pair. Okay. That means this sequence number. 1 second. This ends here and for each block ends here. So after this, say in my marks list, if I had some sequence number 6 who has scored 240. Okay. So now I have picked up this one from marks list. So what is the last of this? 240. Is 240 not equal to 250?
Yes, not equal.
So I will enter the if block. Okay. And max will be what? Last of the pair, that is 240. So now max is 240 and counter is increased by 1. Okay. Now if I come here, remember in my top list.
Pair is maximum than 250, it's meant 260.
No,
If you have 260 after this, see in marks list, it will start with the maximum because it's in descending order. That's why it will start with all the people who have scored 250 first. Then it will go to the next highest. Okay. So till now in top list, I have seen this card and this card. If I'm saying that I have seen these two cards, first two cards. Okay. For this first two cards, for each pair in, first of marks list. Just a second. So max is last of first of marks list.
Ma'am, in the find top, there was not equal to sign. So we cannot have two same marks.
In the final top, there was no equal sign. Let me check.
There was no equal sign. Find the top procedure.
No, top is what? Top is just a single list, right? It is not a list of lists. It is just two things in a single list, sequence number and that. Now, when I did marks list, then I told you that every time we find the highest, we are removing that and going to the next person. So it will contain, marks list will contain those people also who have scored the highest marks. All those people.
Okay.
And then after we have executed for those people, then I go to the next highest, then the next highest, like this till I reach the person with the lowest score. Okay. So here, till counter is less than 4, the top list gets appended. Okay. So top list will contain how many elements? Can you tell me? If counter starts from 1?
3 elements.
3 elements
Top
only.
3 elements.
Top 3 elements. Top 3 elements that now When is counter getting incremented?
When
When
your
max is
pair
not
is
equal
lower
to.
than your first
So now
pair.
tell me, is it always going to be just 3 elements? What if counter is not incremented? I still have to come to this line, like I did here. For the first element in marks list, 2, 250. Okay, I saw that. Okay, what is the max? 250. Now for each pair in mark list, mark list is not anywhere. Is mark list anywhere updated? Marks list is still this, starting from 2, 250 only. Okay, but the max is what? 250. So first counter is 1. Then last of the first thing, that is 250. So 250 is not equal to 250. That is wrong. Okay, but it will still come to this if, na? And counter is less than 4 because counter was initially 1. So top list contains first of this pair. That means top list contains 2. Right? Then when I go and pick the next one, that is this pair. Okay, when I pick this pair, then what is the last of this pair? 250. Is it equal to max or not equal? Max is also 250.
Equal.
So it is equal. So counter is again not incremented because I cannot enter this if block, but I will come to this if and counter is still less than 1. So I will add that to the list. Right? So
If all students are scored the same marks, then we will have all
then
sequence
all of
numbers.
them will come. Yes, all the sequence numbers are going to come. Now, when I go to the third one, now I see 240. Okay. So 240, is it equal to 250? No. So now I can increment counter and make max as this 240. So now max is 240 and counter is 2. So is counter 2 less than 4? Yes. So I will add 6 also. Okay. Now say the next element is someone with sequence number 10 and marks 230. Since it's descending order, so marks has to be less. Right? Less or equal. Then 230 is not equal to 240, right? So now max is updated to what? 230. And counter is again incremented. So counter is 3. So 3 is less than 4, so 10 will also come. Now after this, if there is one more person, sequence number 15, who has scored 200. So now max is 230. 230 and 200, are they matching? No. So max is now what? Updated to 200. And counter is now 4. Is 4 less than 4?
Ma'am, how max is updated 200? Max is 230.
Max is last of the pair that I have currently picked. So currently I have picked this
Started
pair.
the counter with 1, no? But
Started the counter with 1. But am I incrementing for the first 2 pairs? Am I incrementing count? I cannot even enter the if block. How will I increment count? Because this thing is false. Both of these have scored 250. So 250 not equal to 250 is wrong. So I just have to come to this count, this if block. So for the first 2 pairs, when I'm appending their sequence numbers in top list, counter is not incremented. Counter is incremented when I reach this pair, when max is different.
got it.
Okay. So after this, when 15 comes, then 200 becomes the max and counter is incremented to 4. But 4 is not less than 4. So nothing else will be appended to top list. So what is top list going to contain? Look at the
max 3 marks.
No. Is it 3?
Max
It can be
3
any-
marks.
It can be, it depends on the list.
Max
Actually.
3 marks as not
First of all,
sequence number.
top list is not containing your your marks. Top
Right.
list is containing sequence numbers.
Sequence numbers of students who have got the top 3 marks.
A will be the.
See,
Yeah.
option 1 is saying what? List of sequence numbers of students whose total marks is in the top 3 total marks. Is this correct?
Yeah, that's correct.
Yes.
A is correct.
You're saying this is correct.
Yes, because it can be 4 or 5 student also. They are just saying top 3 total marks, not necessarily 3 sequence number. It can be 6 people, but having top 3 total marks. Is that right?
So you're saying that there are going to be any number of people, but their marks should be in top 3 total.
Top total 3, yes.
Yeah.
Correct?
Okay. Let's see the next options, then I'll tell you.
Yeah, thank you.
List of sequence numbers of 3 students whose total, and this is definitely wrong because more than 3 we have seen in our example only. What is option C? List of pairs of sequence number and the total marks of the students whose total marks is in the top 4 total marks.
Not a
Pairs
No.
is incorrect. So list of pairs is incorrect.
It has only
First of all, top list. Okay. We need to find what is top list representing. Is top list representing any pair or single items?
only single.
So it is saying list of pairs of sequence number and total marks. So from here only I can eliminate.
Yeah.
Right.
And D is also incorrect.
D is also same. So option A is correct.
A is
Very good. Okay. See, this type of question you can easily solve now.
Ma'am,
Just, yeah.
I have a doubt. Can you please scroll up?
Hmm.
Okay, so the example that you took for sequence number 2 and 4, we are not incrementing the counter, and we are going to
No,
the
because
next.
max is same.
That I understood. So we are going to the next if block, and we are appending the top list with the sequence number 2 and 4. For 6, we are increasing the counter. For 10, we are increasing the counter, but then 15 will also be included in the top list, right? Because then the
But for
counter will
15,
be.
No. The
for
counter will be
15,
less than 4.
counter
No?
becomes 4. So 4 is not less than 4, no? So I cannot add anything more to the top list.
Ma'am, how does the counter becomes 4 for it?
We initiated counter with 1.
Initially it was 1.
Achha,
Okay.
1, 1.
For
Okay,
2
okay,
and
okay.
4
Now I
I
got it.
didn't. Oh, you thought it was
Achha,
starting
ma'am.
from 0.
Yeah. Okay, got it.
Okay. Next is question 9. So 9 to 11, it is based on the same data. Okay. So read this data carefully. The given, do you have any other sessions from 8?
No, ma'am.
Then we can continue, right?
Yes, ma'am, we have.
Yes.
Yes, we have.
Ma'am, I
Statistics
have
session.
Okay, if you have, you can leave.
Statistics
Those
one.
people, yeah, those people who can stay, you stay. Others, you can leave and watch the recording later. Okay, because these 5 questions I'm going to discuss.
Thank you, ma'am.
Okay.
Thank you.
Thank you, ma'am.
So,
Thank you.
yeah. So this is saying that given pseudocode is executed using a data set having same fields as the words dataset. Words dataset has what? Each card has a single word on it. What is the part of speech? What is the letter count and some sequence number? Correct. So it contains these following words, this paragraph. Okay. Now consider the following information. Unique L. Okay, unique L is a procedure which returns a list of unique elements of list L. Okay, list can have duplicate elements, correct? Is there anything against lists having duplicate elements? Can a list have duplicates or not?
Yes, ma'am.
Yes,
It can
ma'am.
have.
So if a list L is given to this unique procedure as argument, it will return a list containing only the unique elements from that list L. Okay. Next, com number L1 and L2. So it will return just those common elements that are in lists L1 and L2. Whatever common elements are there, it will return that. Max of ABC returns the maximum among A, B, and C. Okay. Upper and lower case are ignored when we are checking a word that belongs to positive list and negative list. Okay. So cases, it is not case sensitive. Okay. Now this is the pseudocode. So let's see what the code is doing. First, it has a positive list which has happy, awesome, nice, fine, best, and cool. These 6 things are in positive list. In negative list, there are actually negative words like dull, worse, ugly, hopeless, bad. Then I have 3 variables. Positive sentence, I think this is short for, then negative sentence, then neutral sentence. Okay, all 3 are assigned the value 0. And there is an empty list called L. Now what it is doing, while table 1 has more rows, read the first row in table 1. What is this table? This paragraph that is given to you. Okay, this is your table. Each word is a row in the table. So first row, X in table 1, L is appended with the word. Without seeing anything, I am appending L with the word. Okay, so what is the first word that is appended? I. Correct? I is appended. Then, if X word has full stop That is, if that word is at the end of a sentence, then you will enter this if block. Okay. But is I at the end of a sentence? No. So when will this condition become true? When I reach Gitark. Right. Here this will become true. Before that, all of these words will just be added to L list, and then this if ends where? Look. This inner if ends here, this else ends here, this outer if ends here, outer else ends here, and this if ends here. And this is the end of the while. Okay. So every time that I read a word which is not at the end of a sentence, I am just going to append that word to my list L. Is this much agreed with everyone?
Yes.
Okay. Now, as soon as I reach Gitark here in the first sentence, now what happens after I have appended it to list L? I see, is the word having full stop? Yes. Now I will enter. Now L is going to be unique L. So now whatever I have stored in L till this point, all of that I will pass as an argument to this unique procedure, which returns what? Only the unique elements, no duplicates in list L, and storing that in L itself. So you tell me, look at this. I ordered this product from Gitark. Are there any duplicate elements present?
No, ma'am.
No. So all of them will be part of list L only, even after the unique procedure. Okay. Now see, pos count is equal to, now I'm finding common elements between positive list and L. That is this list and whatever is L currently. And I'm storing those common elements in the form of a list in this pos count variable. Okay. Or what is, no, 1 second. Common number returns the number of common elements. Okay. So it is not a list. It will return whatever is, how many number of common elements are present between positive list and L. So for the first sentence, let's check. I ordered this product from Gitark. Any of the words, do they match with positive list words? That is happy, awesome, nice.
No, ma'am.
No, ma'am.
No. Nothing is matching. So common number will return 0. That will be stored in pos count. Similarly, negative count you also have to check. Anything is matching?
That is
No,
also a
negative
0.
count?
No, ma'am.
So negative count is also 0 for the first sentence. Now, if pos count is greater than equal to 2 or negative count is greater than equal to 2, so none of them are true. So both are negative for OR condition. That means it will go to the else part. This else, this is the outer else. Okay. This is nested if, this is nested else. This is outer if, this is outer else. So it will come to the outer else. And neutral sentences will be increased by 1. So if it is not part of positive list or negative list, that means it is a neutral sentence. It has no common elements with either positive list or negative list. So it will come to neutral sentence and append the number of neutral sentences by 1. That is, we have found one sentence that is neutral. After this, L is again initialized as an empty list. Understood? So every time that I have checked a complete sentence, L is again reinitialized as an empty list for the next sentence. Clear?
Yes, ma'am.
Yes, ma'am.
So what is the next sentence? I am very happy to share my review regarding this awesome product. So this all will be stored where? In the list L, right? All the unique elements. So all the among all the unique elements, is anything coinciding with positive list? Happy.
Yes, happy.
Awesome.
Awesome.
So happy and awesome. So if these two coincide, then what is pos count going to be? 2.
2.
Is anything coinciding with negative list?
No.
Nothing. So negative list remains 0. Neg count is 0. Now, if pos count is greater than equal to 2, so this part is now true. So I will enter the if blocks or condition. So any one true means I will enter. If pos count is greater than neg count, so 2 is greater than 0. Yes. So positive sentence will be incremented by 1. Understood? So at this point, after I have seen the first and second sentences, let's maintain this. This is pos sen, this is neg sen, and this is neutral sentence. So at this point, this is 1, this is 1, this is 0. Correct? After I've seen the first two sentences. Now, Third sentence, it is not only nice to use, but also has a very cool look. With positive list, what are the coincidences? Nice
And cool.
and cool.
Cool.
Anything with negative list? No.
No, ma'am.
No. So again now, pause count is again 2, neck count is again 0. So which will be incremented? Positive sentence. So this is 2. Okay. Next, I think this is the best product which can be bought in this price range. So best and anything else?
No.
No, ma'am.
Nothing. And in negative list also nothing. So now pause count is 1, neck count is 0. But is pause count greater than equal to 2? No.
No, ma'am.
And neck count is also not greater than equal to 2. So I will go to this else part and increment neutral sentences by 1. So this is part of a neutral sentence. Okay. So both are 2 now. Next.
it will go to neutral sentence.
Yeah. See, it is only a positive sentence if there are more than 2 or more than 2 positive words in it. It is a negative sentence if there are 2 or more than 2 negative words in it. And then also we have to check the positive and negative count. If positive count outweighs the negative count, then only it is a part of positive sentence. Otherwise, it is a part of negative sentence. Understood? Then the only bad thing was the broken and ugly packaging. So with this, where do we find the coincidences?
Bad and ugly.
Bad,
Ugly.
ugly. Anything else? Only bad and ugly. And positive list, nothing. So pause count is, yeah, bad and ugly, 2. Okay. So pause count is 0, neck count is 2. So negative count is greater than equal to 2. Greater than equal to 2. So it will enter the if block. Is positive count greater than negative count? No. So go to the nested else and increment negative sentences by 1. So now this is 1. Understood? Now the last sentence is, I have never seen packaging worse than this before. So worse is what? Coinciding with negative list?
Negative.
Anything else?
Yes.
So neck pause count is 0, neck count is 1. But it is not greater than equal to 2. So both conditions violated. I will go to the outer else part, neutral sentence. So now neutral sentence becomes 3. So 2 positive, 1 negative, 3 neutral. This is what everything that we got. Okay. At the end, there is one thing called comment type, which is finding the maximum of these 3. So what is the max? Neutral. So it will return the number of whatever is the maximum. Okay. So it will return 3 for neutral sentences. Now come to the actual question. Question 9 is asking, at the end of execution, value of positive sentence will be, we already found 2. 10 is neutral sentences, 3. And 11 is negative sentence, I guess. Oh, comment type. So comment type will be what? Neutral sentence, which is the highest. Is this question clear, everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Was this difficult? You tell me.
No, ma'am.
No, ma'am.
Not at all. Just
Yes, ma'am.
every time you are running the code, just run it along with the sentences. Okay, given to you. One by one, pick up the sentences. So now question 12 to 14 is again also based on the same data. So this is the last. Okay. The following pseudocode is executed using Olympics dataset. At the end of execution, medal lists should store the number of players who have won all 3 types of medals and have won at least one type of medal more than one time. So there are 3 types of medals: gold, silver, and bronze. Okay. So medal lists is a list that should contain the number of players who have at least won one medal and more than one in at least one of the categories. So it should be at least 2 or greater than 2 in either gold or silver or bronze. Correct?
Yes, ma'am.
Is the question clear? Now, assume that table 1 is always gets stored after every iteration. Okay. Should we check the Olympics dataset once, because I have forgotten it? Just let me check the dataset once. Okay. And you can also check from your portal.
Ma'am, total
We
it is
don't
not
have
given.
Olympic data set.
You don't have an Olympic
Yes,
data set?
ma'am.
No, ma'am.
At the
No.
start of the mock, it was given as a reference. You can check that out.
Yes.
Oh, it was given. Okay,
Yes.
I'm not sure. Okay, I don't think we'll need it anyway. Let's just solve the question. See, medal list is what? Is it visible? What I'm sharing?
Yes,
Question 12,
ma'am.
visible, na?
Yes, ma'am.
Okay. So medal list is initially 0. Okay. It is storing what? Number of players who have won all 3 types at least one and at least one type more than once. Okay. So it is initially 0 while table 1 has more rows. This is the Olympic data set, right? So read the first row in table 1. Medal list is equal to medal lists plus qualified. Qualified is a procedure which is passing which parameters? Medal dict, repeat dict, and X dot sequence number. Now you will ask something, what is these? What are these 3 things? We have not introduced them anywhere. X sequence number is fine, sequence number of code. What is medal dict and repeat dict? These dictionaries are nowhere given, right? So what we have to do is we have to find the explanation for this by looking at the code itself, that what medal dict and repeat dict can be. Okay. So what is the procedure qualified doing first? It is passing arguments as these 2 dictionaries, medal dictionary, repeat dictionary, and N. N is the sequence number of the card that we have picked. Medals is first a variable which is assigned 0. And repeated is a variable which is assigned false. So repeated is what type of variable?
Boolean.
Boolean. Good. So medals is then assigned length of keys of medal dict N. So if I say keys of medal dict N, from here, what can I say about medal dictionary?
It's a dictionary.
It is a dictionary within a dictionary.
Yes.
Correct. Because for every key, every N, there is again a list of keys. Right? That means medal dictionary itself is a dictionary within a dictionary. So what do I want? I want the length of keys that are corresponding to this N, that is whatever is the sequence number. For that sequence number, that means in medal dict, what are the outer keys? The sequence number of the cards, right? And for each sequence number, there is a separate dictionary. Now I want to find the length of keys for that dictionary. That is how many keys are present in that inner dictionary for sequence number N. Okay. Now repeated is containing what? Repeat dictionary N. So if repeat dictionary N is being stored in repeated, is repeat dictionary, what is it? It's a simple dictionary, right? No nesting. Because if it was nested, then it will also be stored in the form of a dictionary. But repeated is what? It is a Boolean variable. If repeated and medals equal to 3.
If repeated, that is, if repeated is
repeated is storing what? Whatever is stored against the key N. Okay, in repeat dictionary. So definitely repeated is storing some Boolean value. So in repeat dictionary, I think the dictionary structure should be like this. These are the sequence number 1, 2, 3, and against these there are some true false values given. Okay, I don't know what it is, but this is what I think the repeat dictionary structure should be like.
Yes.
Correct?
Correct.
Yes.
So now I'm checking if repeated and repeated means if it is true, if repeated is returning true for sequence number N and medals equal to 3, then return 1, else return 0. Okay. So when is it returning 1? Whenever repeated is true and medals is 3. So these are the 2 conditions in my question, right? That the person should have won at least 1 medal from each category. So that 1 medal from each category thing, that condition is being checked by this part of the code. And the fact that that person has to win at least 1 type of medal more than 1 time, that is checked by this repeated part. Is this much clear? How the 2 conditions are being checked? I don't know yet how this is working.
Can you please show the structure of the medal dictionary as well? Like you showed for the repeated dictionary?
Yeah, see, in medal dictionary, this medal dict you're asking, na?
Yes.
See, medal dict is nothing but it is also containing sequence numbers. Okay. But for each sequence number, there is again some dictionary present. I don't know what is in that dictionary. Okay. I don't
Gold,
know what
silver,
is in
I
those
think
dictionaries.
gold, silver, bronze.
Yeah. So that can be, it is. Yeah. Okay. If you have said it, then yeah.
Okay.
Gold, silver, brown. So it is just keeping a count of each sequence number and how many medals they have won in these categories. Okay. So this is Mendel dictionary. And in this if statement, what I'm asking is, in this if statement, I am checking the main two conditions for our question, that is whether each player has won at least one medal in each category, that is being checked by medals equal to 3, this condition, and whether that person has scored at least 2 medals from the same category or more than 2. Okay, that is checked by this repeated part. If both of these are satisfied, then only we return 1. Where do we return this 1? To medal lists, which is keeping a count of what? It is keeping a count of the number of players who are satisfying these two conditions. Correct. So now read the explanation for this. From line 11, it is clear that medal dict is a dictionary. It is also clear that n is the key of medal dict and the value of medal dict n is again a dictionary. So basically dictionary within dictionary, because the keys function is being applied. So medal dict is a nested dictionary. Now medals is an integer. This medals, it is assigned 0. So what can I say about it? That it is an integer, right? This variable will contain integer only. And it is the number of keys stored in medal dict n. Because of line 11, medals equal to length of keys of medal dict n. So from line 13, as medals equal to 3 is being checked. And the question was about 3 distinct medals when it is evident that the keys of medal dict are gold, silver, and bronze, like you said. So for each sequence number, I have this gold, silver, and bronze. And how many medals I've won in that category. Okay. If medals is tracking the first condition mentioned in the question, then repeated is tracking the second condition. What is the second condition? That in any of the categories, the person should have scored more than 1 medal, right? So as repeated is a Boolean data type, it should either be true or false, and the value of repeat is decided by repeat dictionary n. So repeat dictionary looks like this. Now, as repeat is the tracker of the second condition, which is either the player has won at least 1 medal more than 1 time or not, then medal dictionary is what? Is a dictionary with the keys as sequence number mapped to true if the player has won the medal, right? So here G, S, B, this gold, silver, bronze, these are going to be mapped to true or false values based on whether the player has won in that category or not. Clear?
Yes.
Up to this much, is it clear?
Ma'am,
Yeah.
in line 11, should I say?
Yeah, say.
In line 11, when we read the code, so we say for n sequence, the medal dictionary, we are reading out the, well, like, we are calculating the length of the keys, right?
Yes.
So what you have,
keys of the n.
what you have
Look,
drawn, like what you've written,
I
that
think, look, what I think that here, this thing is only going to track the true ones. Okay. So if a person has scored in gold and silver, then they will have just entries for gold and silver. Okay. If they haven't won a bronze, there will be no entry for bronze. That's what I think. Because then only it makes sense, na? Because otherwise, key to will be same for every sequence number. If I keep track of both true and false, then it will always be 3 for every sequence number, the inner keys. There are only 3 categories. But if we maintain a record of only those categories in which a person has won, like if someone has won in both in gold, silver, bronze, all 3, then their number of keys in that medal dict n for 1, it will be 3. But again for 2, if I check, it will be 2. Why? Because that person has won only gold and silver, no bronze. Right?
Okay.
This makes more sense.
Yes, ma'am. Thank you.
So now it is asking question 12. Which of the following statements is or are true about Medal Dictionary based on the above pseudocode? What is Medal Dictionary that we have created? This. So now let's see the options.
Ma'am, I want to ask one
This-
question.
Yeah.
Ma'am, I want to ask one question. Ma'am, this explanation, as it is given here, will it be given in the exam also?
I'm not exactly sure because this is the only question that I've seen with this kind of explanation. I don't think it will be given. Okay, I think this is part of the solution. You have access to the actual mock paper, na? Have
You're
you
part of
solved
the
the mock
solution.
paper?
Yes, I'm solved.
So there was it given in explanation?
No,
No,
ma'am.
no, ma'am.
Yeah, this should not be given. This you have to decipher, na? That is the actual like if this is given, then there is nothing to this code. This is all you have to do in this question
It is
because
not
look at the
given, that
actual
is-
question.
That
That
why
is
I
the
asked
only
9/11.
challenge.
Yes,
Yeah.
ma'am.
So which is true? Here, check. Medal dict is a procedure which accepts the sequence number. Okay, first of all, is it a procedure?
No. Dictionary, ma'am.
So A option I can easily eliminate. Medal dict is a dictionary with sequence number of players mapped to true if the player has won all three types. Is it just
Yeah,
sequence number
no.
and true and false?
No, ma'am.
No.
It is a nested dictionary with sequence numbers of players mapped to a dictionary with medals as keys, mapped to true if the player has won that medal. Is this?
Like,
Yes.
This is
Yes, I
this is
think.
what we saw, na? So if a
Yeah.
person has won in a certain category, then that category
Then
is
it is
mapped to
true.
true.
Yeah.
Yeah. So this is the answer. Even still see the last option. Medal dict is a dictionary with sequence of numbers of players mapped to list of distinct medals. So it's not like a player, if first player has won 2 medals, it won't be like 1:2. That's not how the structure is. Right. It is a nested dictionary. So again, since nested dictionary is not mentioned, see, easily how you can eliminate none of the options nested dictionary word is mentioned except for C. And you know it's a nested dictionary. So easily you can just click on C in the first go, right? This is also wrong.
What is the D option saying?
The option is saying it is a dictionary with sequence numbers mapped to list of distinct medals.
What's the number of
That
players
means
also you are mapping?
it will be
So
like
that is
this.
wrong.
Gold, silver, like this. This is also wrong.
Okay.
This is still not a nested dictionary. This is list within a dictionary.
Yeah, got
This
it.
gold and silver should be in the dictionary.
Yeah.
Yes.
And the keys function cannot be used on a list, right?
Very good. Keys function cannot be used in a list. But easiest way of eliminating is what? None of the options have nested word in it. Right. So just look at this and click on C. Obviously, don't just look at this, read the whole option. Okay. This is what? Which of the following statements are true about repeat dictionary based on the above pseudocode? So what is repeat dictionary that we found? Like this. Right? So if a person has repeats, then it is mapped to true, otherwise false. So repeat dictionary is a procedure which accepts the sequence number of a player and returns true if the player has won at least one type of medal more than one time.
Procedure.
No, not a
Is
procedure.
it a procedure?
No,
ma'am.
it's not a procedure. It's a dictionary.
But the rest of the thing was true. Now, repeat
Yes,
dictionary is a
Yeah.
dictionary with sequence numbers mapped to number of medals. Is it number of medals to which the player has won more than one time?
No.
No,
True or false?
false.
No, ma'am.
See,
False.
it is saying sequence number mapped to number of medals which the player has won more than one time.
No, it's Boolean.
This doesn't even
It's
make any
Boolean. So it's
sense.
a third option. So fourth.
This is wrong. Repeat dictionary is a dictionary with sequence numbers of players mapped to true if the player has won at least one type of medal more than one time. Is this true?
This is true.
You're
False
saying
Will
this is true.
satisfy what you're
partially
looking
true.
for in
What
the
about
question as well.
Otherwise, it is
what about
false also.
what
If a
about the
person-
false?
Yeah,
You
it's
have to
Yeah,
take
the
false
fourth
into
option is
consideration also. Because see the
Yeah.
code. Here, both possibilities are there. I have to check for true and for false, right?
Yes.
Both the conditions I have to know.
Okay.
So only mapping for true won't give you the correct answer.
Okay.
So this is everything
Yeah.
is correct except for the false condition that
False.
is not
Yeah.
given.
Yeah. Yeah.
So D option is it is a dictionary with sequence numbers of players mapped to true if the player has won at least one type of medal more than once, otherwise mapped to false. So this is correct.
Okay.
Now last question is if
Okay,
now,
ma'am.
let G and B be the list of sequence numbers of players who have won gold medal, silver medal, and bronze medal respectively. Okay. So every player that has won gold is in G list, every player that has won silver is in S list, similarly for bronze. If N is the sequence number of a player, see, these lists are containing just the sequence number of players, okay, not names or anything. If N is the sequence number of a player, then choose the correct implementation of medal dictionary. So that medal dictionary that we just saw, this one. How is it getting built? Okay, that's what they're checking. So which is the right code fragment? Look at the first fragment. First fragment is saying procedure medal dict. So I'm creating this dictionary for sequence number N. Okay, that means I'm creating an entry for sequence number N, right? So count is initially 0. If N is a member of the gold list, these are what? Lists of sequence numbers of players in each category, gold, silver, bronze. If N sequence number is a member of gold, then I will increment count by 1. If he is a member of silver, I will again increment count by 1. And if he is a member of bronze, again count by 1. Okay. So medal dictionary should give me that value, no? That is how many medals that player has won. So how will that get? By incrementing the count by 1. But is this the correct way?
N is given in brackets. So
Here I am not, here,
It's
what
not
am I
in
not
this.
checking? First of all, is this going to create the same structure that we saw?
No, it is one. They have one.
No, ma'am.
One
No.
or not.
Ma'am, why?
Yeah, go on.
medal
Ma'am, why
dict
this is not
N
correct?
N is put in curved brackets. Should it not be in square brackets? For a
I don't know
dictionary?
anything. I'm asking you, is this correct?
No, N should have been in square brackets, no?
Yeah, it's not
In the first line.
It doesn't look like it's.
This is the procedure. So N is passed as an argument, they're saying. But tell me one thing, is medal dictionary a procedure, first of all?
It's a dictionary.
It's
Yeah.
a dictionary. So is this entire thing even possible? Why am I defining a procedure for a dictionary? So this option is definitely wrong. So you should have stopped me in the first place when I said that I have a procedure for medal dictionary. Because it is not how it works.
Yes,
Dictionaries
ma'am.
don't have
Yes.
procedures.
Yes.
So
ma'am.
obviously, option A and option B you can clearly eliminate. Option C, now this is a dictionary. Now let's see what this is doing. Medal dictionary is initially empty. Now you have to read the rows from Olympics table. Read the first row from Olympics dataset. Count is 0. If the sequence number is a member of gold, okay, then it is incrementing count. Again for silver, again for bronze, it is incrementing count. If count is 3, then it is saying sequence for that sequence number, it is assigning the value true. So for every sequence number, it is saying medal dictionary will be either true or false based on the count. So is that the structure of the medal dictionary that we saw?
No, ma'am.
No, ma'am.
We want
No, ma'am.
count.
It should account for, it is first of all a nested dictionary. Is there
No,
any
ma'am.
nesting here?
No, miss.
No, ma'am.
It is just 1:2, 2:false, anything like
Yes,
this.
ma'am.
Okay, so this is also wrong.
Yeah,
That
yeah.
leaves us with option D. So it has to be correct, but how is it correct? Let's see that. Again, medal dictionary is empty. Now read the first row from Olympics dataset. Now see, medal dict sequence number is an empty dictionary. So for the this particular sequence number from this card X, I am creating a separate dictionary. Now this is nesting. Now within that
And then
I'm
it is
checking.
nested also.
Now this is nested because of line 4. If that sequence number is member of the gold list, that is they have won a gold medal, then where will I assign the true value? Within the nested dictionary for sequence number and gold, I will assign true. So for first sequence number, if they have won a gold, then I will assign G to true. Correct. If they have won a silver, then I'll assign S to true. If they haven't won a bronze, then there will be no entry for that. Not false. There will be no entry. Are you seeing anything that is assigning false?
No, ma'am.
It is only assigning true values. See, the dictionary that even we created here.
No, ma'am.
Here also, are there any false values? If false values were to be maintained, then this medal count will always be 3, like I said.
Yes.
Yes, ma'am, you're right.
So, this is the correct implementation. So, option D is answered. Okay, clear this question?
Okay.
Everything we have covered in mock?
Yes, ma'am.
Yes, ma'am.
Okay. So, tell me one thing now, everything that we covered, any question that you are still having confusions in? Other than that big one, that big one, I don't know. It was
Seventh
number 6,
question,
I think.
ma'am.
Question 2.
Which one? Other than question 2, which one?
Question 7. I still don't understand it completely.
7 is this.
That eliminate.
This
Yeah,
one.
remove row. Yeah.
See, I will tell you one more time. Okay. Marks list is having what? First you tell me. Marks list is having these pairs only, right? But in a descending order. Correct? So while that table 1 has more rows. So how many times will this procedure occur? I mean this iteration. How many times will this while loop iterate? Until table 1 is exhausted.
It depends on the number of rows, yes.
So every time one row is getting removed. Okay. So how is that row getting removed? In topper, what am I storing? Find top table 1. This procedure is giving back what? The sequence number and highest marks.
Marks, yes, ma'am.
That pair. But for the first student that I get, right?
Yes.
Now I said that 2 and 250 was the first student. So this is now in my topper. Now after I have found this, remove row does what? Removes the entire row from the table 1 data set for sequence number 2. That is first of topper.
Yes.
Excuse me, ma'am.
Yeah.
Remove row will removing only the sequence number from table 1 now.
No, it will remove the entire row for that sequence number. All the information will be gone. That row itself will be deleted from the data set.
Acha, now I understood. I think the marks list, the topper, that topper is equal to find top, that procedure won't be changed. So the marks list will again like go to the topper one and check what the value is, and then we'll append to it, right?
Right.
Acha,
It will
this
check
is where I
from
was
there.
getting confused.
But every time it will remove that row for the topper. So that the next iteration, you don't count that row.
Yeah.
Okay.
Yeah, now I got it, ma'am. Okay, thank you
Any
so
other
much.
question?
One question, ma'am.
Yeah.
But is this a right way? Because you are in a loop where you are looping with table 1. Is it?
See, actually, this remove row thing you're asking, na?
Yeah.
Whether this can be performed. See, I don't think it is fully feasible to do this within a loop. This is just a situation that's given to you, that if this procedure was possible. Okay. I don't think it can be implemented that way. Because how can you dynamically change a fixed data set with every iteration? That is difficult.
Right. Okay.
Okay. So other than this question, please, you just go through one more time. Okay. This one. Question number 5. Okay. This is a little difficult, right? Not difficult. It's very easy actually, but to decode the question itself is difficult. So you just go through this twice or thrice. That should be fine. And someone was asking question 2. Yeah. Are you asking some?
This question at the last, for the time, time.
Should you take what?
Such questions at the last.
Yeah, exactly. Take it at the last. If you see a very big, lengthy question, then keep it for the last. Because, if you start doing this kind of question, it is going to take up some time, and then you will get all nervous about how much time is left. So first do the ones that look easy with the small pseudocodes.
Okay.
Okay, so question 2, I will explain one more time for that boy who joined late. Okay, others, if you don't
Ma'am,
have any more question, you can. Yeah.
some questions will be like qualified, ma'am.
Questions will be like qualifier. It will be a little difficult than qualifier. Qualifier was initial weeks, no? This is a little advanced. So your syllabus is from week 1 to week 8 only, right? All of the 8 weeks. But mainly weightage will be on weeks 5 to 8. Okay, and dictionary and lists are the most important concepts from which questions will come. Okay, it will be definitely a little harder, but if you are able to solve this mock, you will think that it is easy. Okay. Just one thing. I actually have something to join after this. So can you please, the person who joined late, can you please go through the recording once, question 2? If you don't understand, you can send me a mail. Is that all right?
Okay, ma'am.
Yeah. Okay. Thank you, everyone, and all the best for your exam.
Thank you so much, ma'am. Thank you.
Ma'am? Hello, ma'am. Can you give me your mail ID, ma'am?
Sure.
Hello?
Am I audible?
Yes.
Jammu में
ma'am.
Yeah.
Jammu
Mail ID I'm putting in the chat. Okay, I'm putting it in the chat.
Okay.
और ये बात ही बताइए ये कैसे कपड़े हैं इसके इसके कैसे कपड़े हैं 10 नंबर वाले के
Mute yourself, no? If you don't have anything to say, mute yourself. How many times I will say this, saying this from the first day.
Okay, ma'am. Got it.